We'll go ahead and get started. So again, good morning, everyone, and welcome to the third workshop in the 2026 Vapor Intrusion series hosted by the CalEPA Vapor Intrusion Workgroup. My name is Julie Johnson, and I am the Senior Engineering Geologist managing the Site Cleanup and Department of Defense programs in the State Water Board's Division of Water Quality. I will be your moderator for today's workshop. Next slide, please. So before we get started, I want to run through some logistics. During the presentations, everyone is in a listen and participate role. This means that microphones are muted and the chat and video are disabled. Automatic closed captions have been turned on. If you would like to follow along with the closed captions, please click on the CC button on the toolbar at the bottom of your screen. Please note we will not be taking questions through the chat feature today. Again, it's disabled for participants. CalEPA VI Workgroup the CalEPA VI Workgroup team will be busy answering questions through the Q&A feature throughout the workshop. So if you do have questions as the presentations are going, please use the Q&A feature at the bottom of the screen and send in your questions. The chat feature will be used by the workgroup members to send out email addresses, website links, and any other info related to the workshop. So let's see. So today's workshop is being recorded, and by joining, you agree to be recorded. The workshop is scheduled from 9 to 11:30 a.m. However, the presentations are pretty hefty today, and we may run a little over time, just letting you know with the Q&A. If we reach the end of the workshop and we're not able to answer all the questions, please reach out to us at dwq-vaporintrusion@waterboards.ca.gov or vaporintrusion@dtsc.ca.gov. Both of these email addresses will get you in touch with the CalEPA workgroup team. Both emails have been dropped into the chat box for your convenience. The recording of the workshop and copies of the slides will be available about 1.5 weeks from now. The recording will be posted on the State Water Board's and DTSC's vapor intrusion websites, and the slides will be available on our FTP site. If you've already gotten the login access to download slides from a previous workshop, it's the exact same information. Just give us about 1.5 weeks to get the materials online. Finally, please note that our presenters are hosting this workshop from multiple locations throughout California. We ask that you bear with us if there are any time lags, pauses, or technical difficulties. We appreciate your patience, understanding, and cooperation in making today's workshop a success. Next slide, please. All right, onto the content. So this slide shows the CalEPA VI Workgroup's series of vapor intrusion workshops. The kickoff was held in July of last year, and feedback from that workshop was used to create this 2026 series. Today, we are in the third workshop, Holistic Approach Part 1, Conceptual Site Model and Best Practices. Next up in May is the sister to today's workshop, Holistic Approach Part 2, Path to Closure and Collective Decision Making. And the final workshop in the series will be Vapor Intrusion Data in June. Notification emails will be sent out on our listservs, and registration links will be posted on the State Water Board's and DTSC's vapor intrusion websites when they are available. Next slide, please. So today we will have opening remarks from the Department of Toxic Substances Control, a presentation on building and refining conceptual site models and best practices, and 2 case studies that illustrate adaptive case management or the holistic approach, and vapor intrusion guidance documents to effectively protect human health and move a case forward through the cleanup process. We'll take a short break after the first presentation and before the final Q&A, and we've slotted about 15 minutes for Q&A directly after the first case study. Also, please note that there will be a Zoom survey at the end of the workshop. If you have time, we'd greatly appreciate your feedback. We read all the responses and we use that feedback to improve future workshops. Next slide, please. So today's presenters are Andrew Levitt from the Department of Toxic Substances Control, J.W. Jones from Environmental Navigation Services, Inc., Saraswati Podel Acharya from the State Water Resources Control Board, and Jessica Law from the Santa Ana Regional Water Quality Control Board. Next slide, please. Now for a quick poll question. So how familiar are you with the 2023 supplemental guidance. Excellent. I'll give it just about another 30 seconds or so for everybody to drop in their responses. All right. We're still getting responses coming in. Awesome. Looks like we're slowing down. All right. Can we go ahead and see the results, please? Excellent. Thank you. So it looks like we have quite a bit of people attending who are very or somewhat familiar with the guidance. And then we do have a decent amount of not much and not at all, and a few who have never heard of it. Excellent. So we plan to talk about the guidance somewhat today and hopefully get everyone a little more familiar with it and how it fits into the cleanup process. Thank you all. Next slide, please. All right, and with that, I'll go ahead and pass the mic to Craig Sanchez, Division Chief of the Department of Toxic Substances Control, for some opening remarks. To you, Craig.
Thank you. Good morning, everyone. Today's workshop is the first part of our holistic approach to vapor intrusion. In this session, we will focus on the conceptual site model and best business practices for conducting successful vapor intrusion investigations and beyond. The supplemental vapor intrusion guidance has been valuable in providing a consistent statewide framework for screening and evaluating potential vapor intrusion. Over the next few workshops, we will demonstrate a path forward that emphasizes multiple lines of evidence and incorporates site-specific data to ensure decisions remain both health protective and practical. This will include a multidisciplinary approach to move past initial screening levels and default attenuation factors, understand flexibility within guidance, apply high-resolution site characterization to make cost-effective, data-driven decisions, balance mitigation with remediation, use multiple lines of evidence to support risk management decisions, and identify future risks and viable paths to closure. While many of these concepts are not new, the framework in which they will be presented aims to help regulators and environmental professionals apply them more effectively and move sites towards closure. I want to thank everyone for attending today, and with that, I will turn it over to Andrew.
Hi, my name is Andrew Levitt. I'm a senior geologist with the DTSC, and I'm going to start us off with an introduction to the holistic approach. Next slide. There are three very important concepts that are vital to applying adaptive case management, or what we're calling the holistic approach. That's the conceptual site model, or CSM, the VI toolbox, and multiple lines of evidence. I want to start us with the CSM. Before I dive deeper into the CSM itself, let's go over the results of the survey question that was included in your registration. We asked everyone to tell us how often they update a VI site's CSM. The options were always, mostly, sometimes, rarely, and never. As of March 6th, when I made this chart, we had 421 registrants. While there was no majority, sometimes was the most common answer at 36%, followed by always at 27% and mostly at 24%. Rarely and never were chosen the least at 10% and 3%, respectively. Now, when combined, always and mostly represented 51% of the responses, which is good, because developing and updating or refining a site's CSM is crucial to understanding a site and moving it forward in the cleanup process. If you rarely or never update the CSM, it becomes extremely challenging to move the project along by making data-driven decisions. Next slide. So let's look a little closer at the CSM, which can be seen as the picture of what's going on at the site. It's essentially the presentation of all of the lines of evidence we have for a site. It allows us to use it to make data-driven decisions for the site during the entire life cycle of a project. And that's an important concept to remember. the CSM is a living document that we modify and refine with each new piece of data as part of our adaptive case management. The CSM essentially integrates site data and assumptions to allow us to identify existing data gaps, investigative strategies, inform the risk management, assess and choose the remedy, and decide if and when a project is ready for closure. A CSM may be presented at any phase of a project and can be used to show current knowledge and the progression of an investigation as questions are answered by fieldwork. And remember, the CSM is not limited to the property boundaries and should include off-site migration of contamination. And when building that CSM, if we focus on identifying and addressing preferential pathways and the source area first, we can move swifter to protect human health, which then always allows us not to burn through budgets on initial site characterization and risk management. Finally, a clearly presented CSM can always help provide transparent communication to the public and to stakeholders. Next slide. So what should the cleanup process look like for a typical site when applying the holistic approach? Well, it'll start with the site investigation phase. Using all the tools in our VI toolbox, which I'll discuss more in a bit, to collect the necessary data or lines of evidence, to more efficiently build a robust CSM and delineate the source area. While complete characterization remains important, the holistic approach puts an emphasis on source area delineation so we can remove it and be more protective of human health. Also, it allows us to be more targeted when making data-driven decisions about monitoring well and probe networks, which can quickly deplete budgets and drag out project timelines. Once the source area is delineated, we want to remove it. The methods of doing so aren't anything new. We're just trying to get there earlier in the project lifecycle. We also want to put a greater emphasis on short-term mitigation measures to address more urgent concerns to human health, particularly during the investigation and source removal stages. When indoor air concentrations indicate their need, we've always taken these actions. We simply want to make sure the project teams are prepared to use these measures, particularly when something like sealing up a few cracks may greatly reduce human health risk without depleting a project's budget. Once a source area is addressed, we can move to full-scale remediation, which may include steps like source polishing, addressing the distal plume, or more long-term mitigation measures. Finally, we'll move to project closeout, whether that's in the form of complete case closure or long-term stewardship. And I'll touch a little bit more on those on the closure issue later on. Now, before I move on from this slide, I want to quickly point out the three bubbles that I have running the entire length of the project. First, operation, maintenance, and monitoring, also known as OM&M, is shown to run the entire project length. But of course, this will change site by site. It will depend on when in the life cycle remediation or mitigation is starting. For example, if short-term mitigation measures are put in place during the investigation stage, that's where OM&M would start. Secondly, we have several available VI guidance documents. While we may seek to utilize the flexibility provided therein, we want to make sure that each of these steps are consistent with existing guidance. And lastly, but possibly most importantly, there's community engagement. CalEPA wants to better engage communities early, often, and using clear and transparent language. Hopefully, this will make sure that everyone has a common understanding of a site, contamination, potential risks, and risk management actions that may be taken to reduce said risks, all of which should result in projects moving forward more smoothly. Next slide, please. Okay, so to get through this cleanup process, we're going to look at our VI toolbox. I'm going to spend a little time on this table because it shows just how many tools that we have at our disposal for evaluating and addressing VI at a site. And while this table may be comprehensive, I know that there are additional tools not listed. The point of this table is to simply show that during each phase of the project, we have many options. So let's look closer at site investigation. While using traditional methods such as active soil gas sampling will work to delineate the source area, advancements in both technology and communication has brought us high-resolution site characterization, or high-res characterization, which may be far more efficient. For those not familiar, high-res site characterization combines a higher density of sampling locations with the use of multiple investigation tools and real-time communication to more efficiently characterize impacted media, plume extents, subsurface lithology, and hydrology, all of which will allow you to be more effective in decision making about both the investigation and cleanup sides of a project. Many of the tools we use for high resolution site characterization are considered quote newer or advanced, but we have much more data on some of these advanced tools, so they shouldn't be looked at as fringe anymore. However, it is important to understand some of the limitations of the tools as well as how and when to use them. For some tools, the quality of the data may not be adequate for health risk assessment, but the method may more quickly provide information important to understanding the site conditions and/or the nature and distribution of contamination. So, for example, passive soil vapor sampling. You install a sorbent vapor sampler in the upper 2 to 3 feet of the subsurface and allow it to collect soil vapor in its natural state over 1 to 2 weeks. Passive soil gas sampling is great. It's a great tool for determining lateral delineation, especially in the source area, but not appropriate for risk assessment and vertical delineation. And it should be noted that most labs now who work on passive soil gas can convert data and give you concentrations. Next, we have vertical soil profiling tools like CPT, MIHPT, and UVA. These tools get you great lithologic, hydrogeologic, and overall VOC data, but won't get you concentration data for individual chemicals. So similar to passive soil gas, it's great for delineation, and in this case, vertical distribution of contamination. Many of these tools can also be combined, like CPT and MIHPT, so you're getting a lot of data in each boring. And while you're downhole, you can collect targeted soil samples and/or use hydropunch to grab groundwater samples to confirm the MIHPT data. When used together, these tools can often help delineate a vapor plume laterally and vertically far more efficiently than traditional methods. Think months instead of years. And traditional sampling will still have its place. It's simply done far more strategically. The passive soil gas can be used to be more targeted when installing your permanent soil vapor probes and groundwater monitoring network. And the soil profiling data can be used to be more targeted on your depths of those permanent probes and the well screen intervals. Then, once installed, you can use active sampling methods to collect samples that can be used for risk assessments. And also, the passive soil gas data can be used to identify buildings and be more targeted in identifying buildings that may need indoor air sampling, which can then be done with either active or passive sampling methods. Some of these tools are far more efficient for answering some of the more complex questions and challenges at a site. For example, VI has been identified at a building. TCE concentrations exceed urgent action levels. In response, you put several short-term mitigation measures in place. But when you conduct the performance monitoring, there's been little to no change. Instead of performing numerous investigations to determine the reason, you could use real-time monitoring. And more specifically, the portable field gas chromatographs, or GCs, may be the ideal tool. Portable GCs are equipped with various detectors and a mass spectrometer. These devices are able to detect and quantify many vapor-forming chemicals in real time. Tubing is run from the analyzer to various sampling locations throughout the building, and they yield chemical-specific concentration data that may be used for risk assessment. But make sure to check with your toxicologist on that. While it can be expensive and has limited application for soil vapor sampling, real-time monitoring tools can be cost-effective and are great for evaluating preferential pathways, VI patterns like temporal variability, and differentiating between background sources and VI, which could answer why the mitigation measures weren't working. When we look at source removal and full-scale remediation, none of these tools are considered new or advanced. These are tools that we've been using for years. We are simply trying to use them earlier in the process to be more protective of human health. It can also be noted that many of the tools used for site investigations may also be used for long-term stewardship. I want to make it clear that we understand that every site is different, and therefore not all of these tools will work at every site. There are exceptions for every technology, but if we look again to the site investigation tools, for example, many of these tools will work at a large number of sites. The toolbox is vast and gives us options. We simply want to see the most appropriate tool chosen for the task at hand. And I also want to note that a great source of information for evaluating VI is ITRC's recently published VI Toolkit, which a link has been provided for in the chat. Next slide, please. So how do we build the robust CSM? Well, we use multiple lines of evidence. So lines of evidence, or LOE, are all of the data and information that exists for a site. Each LOE should be weighed based on relevance, or how much an LOE helps to answer the question being asked, representativeness, or does the information accurately replicate the actual conditions, and quality, or was the sampling or analysis performed using acceptable protocols. The same LOE may be weighted differently for another site, a different building at the same site, other scenarios for the same building, like change of condition or operation, or even for a separate sampling event within the same building or same site. In other words, context is critical. For example, you collect indoor air data in a building at your site. But how useful is that data? Well, have you collected enough to account for both spatial and temporal variability? Have you collected paired sub-slab vapor data? If yes, to both of those questions, your data may hold more weight. But if I added that the redevelopment plans have the building being demolished and replaced with a new one, now that data holds much less weight. And the weight of some LOE will change as the project moves forward. For example, we apply attenuation factors to soil vapor data to estimate indoor air concentrations. But once you collect actual indoor air data, the estimated concentrations hold less weight for estimating current potential health risks. Once the LOE has been weighted, we use multiple lines of evidence, or a multiple LOE approach, sometimes called MLE, to evaluate, interpret, and integrate all of the information and data for the site. When building your CSM, we use the multiple LOE approach to answer key questions known as data quality objectives, or DQOs, like, is contamination identified? If so, what media are impacted? And by media, I'm referring to soil vapor, subslab vapor, groundwater, and air. Other questions include, how far has it spread? What is the estimated amount of contamination? Who may be affected by the contamination? And is there an immediate risk? We continue using the multiple LOE approach throughout the life cycle of a project. So once the picture is painted, we'll use MLE to determine if short-term mitigation measures are warranted, which would address more urgent health risks. Choose the appropriate remedy, establish cleanup levels, monitor performance of said remedy, and determine if a project is ready for closeout. In other words, we are continuing to use MLE to make data-driven decisions for a site cradle to grave. And how do we collect those LOE? That brings us back to the toolbox and picking the best tool for the LOE you're seeking. So using two of the examples that I discussed on the previous slide, passive soil vapor sampling and soil profiling tools can be used to collect multiple LOE, like identifying the locations and depths of both known and unknown source areas, and then using that data to then design the monitoring well and soil vapor probe networks and to determine which buildings need indoor air sampling. Now, before I move on from MLE, I do want to note that since the release of the 2023 SVIG, it seems that both regulators and public stakeholders in California have placed too much focus on using MLE, at least as a term, to support the use of alternative attenuation factors, or AFs. While yes, we can use MLE to estimate site-specific attenuation factors, it's only a small part of how vital MLE is to the entire project lifecycle. Next slide. So as a CSM changes and gets refined throughout the entire lifecycle, so do our DQOs. So DQOs we established first, they tend to be more broad. These are the big questions mentioned on the previous slide, like, is contamination identified? What media is impacted? How spread out is it? Who's affected? As the project progresses and we meet these DQOs, additional, more specific questions must be established, like, is there a complete VI pathway? Are there potential preferential pathways? What is the human health risk? What is the geology and hydrogeology of the subsurface? One DQO that is important and interfaces with our risk-based decision-making process is whether or not to set a preliminary goal for indoor air, like a hazard quotient of 1 or some other defined risk level. To meet this DQO, we may initiate source removal and/or short-term mitigation measures, but it's important that that can be done while continuing site characterization beyond the source area. Next slide, please. So to sum up, what are some best practices for a successful VI case? Well, first and foremost, it's the application of a more adaptive approach to case management. So we raid the VI toolbox, use the appropriate tools to collect LOE, and build a robust CSM. Then we use the multiple LOE approach with that CSM to support data-driven management decisions throughout the project's entire lifecycle. This will help achieve that goal of more quickly evaluating and addressing potential VI health risks in a more cost-effective manner. And part of that adaptive case management is optimizing early source removal to be more protective of human health and utilizing short-term mitigation measures to address more urgent risk concerns. Next is engagement with, next slide. My bad. Next is engaging with the community early, often, and in a clear manner. Starting that discussion from the get-go may avoid major delays down the line. And for public stakeholders, we want to make sure communication is transparent and collaborative. This will help ensure that both regulators and regulated have a common understanding of the site, contamination, potential risks, and risk management actions that may be taken to reduce those risks. Now, we've used the holistic approach, engaged and involved stakeholders in the community, removed the source, implemented any necessary mitigation measures, all while staying consistent with state guidance. But where does that all lead? Well, the final step in the holistic approach is understanding paths to closure. And I want to emphasize the plurality of this, paths. Understanding that no further action may not be in the cards for your site. So changing your viewpoint to how can we move this project along to get to some sort of, quote, endpoint while protecting human health and the environment. Next. Okay, so with that, we're going to take a 5-minute break. When we come back, Jay Jones will present the first of two case studies, and it should be noted that these are two out of hundreds of cases that we have here with CalEPA. So, and please note that we do intend on having a Q&A session after the two case studies.
I love the music. All right, welcome back, everybody, from the break. Next slide, please. Thank you so much. All right, so now we'll begin the case study number 1, a commercial vapor intrusion site with J.W. Jones from Environmental Navigation Services, Inc. And following up by Saraswati Podel Acharya from the State Water Resources Control Board. So Jay, I'll go ahead and pass it to you. We can go ahead and... There we go.
Okay.
Hi, Jay.
Good morning. Hi,
Good
my name
morning.
is Jay Jones. I'm a professional geologist and registered geophysicist here in California. Been based in San Diego for quite a while. I've been working on vapor intrusion cases, I've just realized now, for almost 30 years here in San Diego. So this is not a new story. So hopefully I have a lot of experience I can bring to this talk. Oh, is there an alert? Do I have to start my video? There we go. Okay, very good. So what I want to do is I want to introduce a case that property that we've been working on now for about 5 years. Next slide, please. And it's fairly complicated. It's a site that's been under investigation for quite a while. Case in point, we have 4 monitoring wells that we're working with that were installed in 1993, and we're still using them. So this is not unusual. These sites seem to go on forever in some cases. It has a long history. Again, I've been working about 5 years. And what I want to do is just highlight some of the few what I consider lessons learned I think are applicable to many VI projects. And then I'm going to close out with 3 examples of high resolution site characterization methods, such as the ones that Andrew was talking about, that I think are really critical. This was a project funded by SCAP. We're very thankful for that. Nothing really would have happened without the funding from SCAP. Next. All right, so the site's located in San Diego. We're just north of the airport. The dotted blue line you see there is where San Diego Bay used to be. All the land where you see where the airport was hydraulic fill, dredged from the bay to make the bay more useful. So our site used to be next to San Diego Bay. It has some importance because what this means is this is really just a VI case only. We have non-beneficial use designation for groundwater, so we're not worried about drinking water. So we really are focused here on VI. Next. Okay, so this is an example site. It's a former dry cleaners. It's kind of a classic case. You may have, you work on dry cleaner cases, you'll see some of these come up from time to time. This is one that started in the early 50s, operated for almost into the early 2000s. There were 2 dry cleaner locations over time within a building. The building was expanded over time. Conspicuous feature of this site is that there was a 100-gallon above ground storage tank filled with PCE, tetrachloroethylene, and it was all used for gravity fed to dry cleaners, and disposal was to floor drains. It was all legal, many years of it. We don't have data. This is also combined with a lot of conventional washing. So there's a lot of soapy water combined with the PCE over time. So we have pretty good historical data. I'll go through that in a minute. And early on, we suspected there was lots of PC. Our initial estimate, there was about 2 metric tons, 4,400 pounds of PC in the ground. After high resolution work, we estimated probably on the order of 6 metric tons. So it really tripled, shows you the importance of the HRSC. Next. Okay, so first lesson learned is phase 1s are good, but you got to go further than that. You really need to dig into the building details, figure out how it's constructed, where the operations are, where the sewer lines are, and really try to understand the site from a practical standpoint. In many regards, how the building is operated what was done in the building and what is currently being done in the building is almost as important as any of the subsurface data you're going to get. Because when you think about it, vapor intrusion is two things. One is the vapor coming into the building, and then two, what happens when it gets in the building. And that's what we want to focus on here, looking at the history and building details. This shows us two things that happened. So the lower left gray is the original building from the 50s. It had one dry cleaner in it. It worked so well that they expanded the business, kind of an L-shaped expansion on the building, and really got into a large-scale dry cleaning facility. And that's basically what happened as we got into it. We had to start chasing both of these features. So again, the history is really important. You need building details, construction diagrams, permitting, whatever. So you got to go much deeper than the phase one. Another thing that's really important that we found was hugely important was work with the people who have hands-on experience with the building. Get to know the plumbers, get to know the heating, ventilation, air conditioning contractors. Get to know these people early in the project because they can tell you an awful lot about what's going on in the building that you wouldn't find out otherwise. Next. All right, so here's a picture of the site. The lower right shows what we call the PCE source area. The building I just showed you is in the lower left of the corner. There's multiple properties on this block. We're involved with investigation, mitigation, and remediation, and all the buildings on this property. I'm going to focus only on the one on the lower left today. You can see on the upper left, you can see flip the opposite version of the same picture. Really hard, very logistically challenging. That's fairly common in a lot of the sites that I've seen over the years, is that we're dealing with an urban environment, and it can be quite difficult to logistically bring in drill rigs and do a lot of the work that we like to do for subsurface investigation. Next. So here's a cartoon conceptual site model, give you a quick idea what's going on here. Two features of high level importance. First of all, on the top, you can see that we had a fairly extensive development of mobile dry cleaners, conventional washing and cleaning, and this above ground storage tank I mentioned to you. Sewer disposal. We've mapped out all the sewer lines, worked closely with the plumber to figure all that out. Second key element of this is groundwater is at 8 feet. So groundwater is a key component of all our vapor intrusion investigation, because what's happening is you have dissolved phase PCE, it partitions into the vapor phase, and it acts as a long-term source for vapor intrusion. So we have to really consider groundwater in this case fairly good detail. So with depth, the 1, 2, 3, 4 on the left gives you an idea of what really kind of conceptual we're dealing with. One is an 8-foot vadose zone. Two, we have this thin wedge of a unconfined aquifer system. Facility sand, sandy silt. Permeability is on the order of 10 to the minus 3 centimeters per second. Not super high permeability, but it is higher permeability in the next layer, which is a very dense, continuous clay sand. So between 5 and 25 feet thick. It is really low permeability. It's really dense. It has permeabilities in the order of 10 to the minus 4, 10 to the minus 5 centimeters per second. It's for reference, 10 to the minus 6 is a landfill liner. So it's really low permeability. Conceptually, what we found is that a lot of the PC that came out of the tanks and the dry cleaning machines has traveled down into this and is pretty much stuck in this clay sand. So we have a large source of DNAPL buried at depth, stuck in this clay sand. Beneath that, there's interbedded silty sand, sandy silt, a little better permeability. And then around 20 to 30 feet, we hit a saltwater layer. And that's respect. And you go back and think about it. We used to be next to the bay. We still have residual saltwater out here. So I'm going to go talk about this in other parts of this presentation, but you're going to see these multiple layers come back time and time again in terms of how we have to evaluate, investigate the subsurface, and also and ultimately towards remediation. Next. All right, so the concerns, again, it's non-beneficial groundwater use, so our focus is all VI. So I want to go through three of our lessons learned. So initially, when we got into this site, indoor air concentrations were quite high. We're in the hundreds of micrograms per cubic meter of PC. Again, that's versus the commercial level of 2. So we're hundreds of times higher than it should be. And the 3 lessons learned I want to talk about is 1, what we can do just doing reconnaissance in the building and really just trying to physically sort out what's going on for vapor intrusion from a vapor conduit standpoint. Look at the ventilation systems in the building and figure out what the operations are doing and how that affects the VI. And then talk about some of our initial mitigation and interim remediation work that we did using both excavation and soil vapor extraction. Again, referring back to what Andrew had told you about, was just we can start early. We don't have to wait to evaluate the whole site. There are some things that are very obvious that we can work on. Next. So the first one is PID reconnaissance. So the photoionization detector is a real common handheld device. Just take it and go in the building. Take the history and building details and start scanning. Okay, look for cracks, look for drains. Work with the plumber, figure out what's going on. The plumber can locate the pipes. You can do pipe inspection work. They can tell you how deep they are, where they are. Our goal really is to try to understand kind of what happened and then what some of the potential vapor conduit pathways we have. So you're going to go into this, use the PID, you're going to find places. You're going to see drains. You're going to find bases of toilets. The point of this is that you're going to find locations where there's vapor coming up out of the slab and fix the obvious. You know, we have people in the building. Fix it now. There's no reason to wait. Next. So here's an example. This is the back of the old dry cleaner. We knew that there were floor drains. Didn't see them, but then after pulling some materials out, lo and behold, we found a floor drain from the 1950s. It was still in place. The upper middle shows the PID. It's registering 10,000 ppb. It was quite high in PCE. We got busy with the plumber. He got his tracing tools out. We tried to clean it out. We were really unsuccessful. The line had collapsed, but we knew we had a lot of vapor coming up. So we were there, and the next day went to the metal shop and got a big plate and just basically came in and sealed it and covered up that hole. Really did a lot to try to reduce our vapor intrusion problem immediately just by using a steel plate. Next. So another trick that we borrowed from the radon mitigation world was this thing called a vapor drain. It's in the upper right. Basically, it's a valved drain. So when you're not using the drain, it seals and stops vapor from coming up. In this case, it's originally was designed to stop radon, but it works perfectly well for our vapor. So you install these in the drain holes. And you can see in the lower right how the plumber had done this, and they fit in there quite nicely. And what they do is they really do cut out this vapor conduit. It helps reduce the flow of vapor coming up into the building. Again, these are all locations that we sniffed out basically with the PID. So we were able to quickly mitigate multiple active vapor conduits. Again, why wait? You know, we have people in the building. Let's fix it while we can. Next. So another lesson learned is, and I've seen this on multiple sites, get a professional involved with the heating, ventilation, and AC. Fresh air is not optional, okay? The California Code of Regulation Title 24 requires outside air for residential and commercial buildings. This has nothing to do with our industry of vapor intrusion. It's simply necessary for healthy air in a building, okay? So use a certified air balance professionals. There are a couple certification agencies. Use them. I've tried other folks, and they don't really know what you're talking about when you're trying to get detailed measurements of what's going on in terms of the HVAC systems. These all follow standardized engineering procedures and calculations. It's a well-established field. Next. So here's an example of an HVAC air balance. This is in the original dry cleaner. And it's the kitchen fans that were being used. It's now been converted, not converted, it's now being used as a pizza restaurant. And the point of it is that if you look at the fans that are being used for the kitchen, there was a unbalanced. They were unbalanced. So we were basically getting a lot of vacuum from the kitchen exhaust fans. Okay, and we were able to fix that. Next slide, please. So here's the drawing of it. You'll see this is a report from the air balance professional. The plate that I was talking about, the long skinny building, the plate, the long skinny suite, excuse me. The old drain plate was in the back of it. This is where the dry cleaner machine was located. And then in the middle is the kitchen. And there's two symbols here. You got KEF and MAU. So kitchen exhaust fan is the fans used for their cooking equipment. And makeup air unit is the air that should be brought back into the building to balance out the kitchen air fans, exhaust fans. Next, please. So here's the report, came back. The makeup air was coming in at about 188 cubic feet per minute. So basically what they do is you just take a shroud, put it on and then returns and the vents and measure how much air is flowing through the system. So the makeup air was running 188 CFM. The exhaust fans, about 6,000 CFM. So basically, the exhaust fans are acting as a vacuum. So that really helped explain why we're seeing so much vapor coming up out of the floor drains and other cracks in the floor. Next. So there's our friend Jesus, the chef. This is the pizza kitchen. You can see the size of these vent fans. These things are running about 3,000 CFM each. And the makeup air, which is deducting on the left, is supposed to make up or balance out that airflow. So what we did to fix that was, and this was part of our project, was to increase the flow of air from the makeup air. And also in the back of the building, we were able to open up some window space essentially to try to get some more ventilation. So how did it go? So we started working on this project in 2020. Before we got here, indoor air concentration of PC in this suite was 730, and TC was also pretty high. It was 5.7. We put in the plates and the vapor drains, came back and sampled the next month. It was 76. We thought, hey, we're doing pretty well. Well, comes July, we sampled again, bumped up to 370. There's two factors here. One, we're coming out of COVID, so there's more activity. And two, it was summer, it was hot, and I think some of that contributed to the increase in volatilization. So the next month we go, well, we better fix the HVAC. So we did that. And then a few months later, we started SVE. Within a year, we found that we were able to get the concentrations down below the criteria 2 and ND and TC. So, and we've maintained that. So we feel pretty good that a lot of this was successful because we were able to manage the HVAC system. Next. Again, it's not too late. It's never too early. Just get busy, go back, revisit cracks, toilets, drains. Go back with the PID from time to time. It's cheap. It's simple. Generally, the folks that are on site, it takes very little just to walk around with these. Fix the HVAC. This is a long-term fix. The occupants need fresh air. I found over the years that a lot of the buildings, they don't have outside air exchange because it costs money to condition, the heat, or cool the air. So a lot of these systems are plugged off. And if just by simply fixing the HVAC, you can do a lot to restore healthy conditions within a building. Further, as you're getting into the projects, floor coatings would be helpful. And then over time, we're going to be looking at, in a lot of cases, some sort of SV. So start thinking about what you're going to do with that. Next. All right, so when we got into this, we did some, really quick action before we really had a full handle on the whole site because we knew we had a really significant source area. So we did some excavation where it was feasible, and we also started planning ahead to SVE. Both of these are called presumptive remedies. Now, this is an older term out of CERCLA, but basically it says that we've done this enough. We know what we're doing. Let's just proceed. We don't need an extensive study to just determine what the precise remediation method is necessary. These things work. They're cost effective. Don't waste a whole lot of time trying to figure out what else to do. Next. So excavation. So we had a vacant suite. This was in the second dry cleaner, which is in the bigger operation that was expanded in the 60s. And we did it as feasible. Point here is be careful. Get a structural engineer to assess and guide. It's very disruptive to be cutting holes in slabs, and you don't want to destroy the building trying to get after the soil. This allowed us, by digging some holes, allowed us to combine some multiple goals. So we were able to take these trenches we dug, backfill with gravel, set up an SVE system. We also were able to put in additional piping. Something that you always have in the back of your head is, what are you going to do for remediation? Remediation nowadays seems to be tending towards more in situ methods, and they're going to be either chemical oxidation or chemical reduction. They use liquid reagents, so if you can put some extra PVC pipe in the ground while you have a hole in the ground, go for it, because the extra PVC is actually fairly low cost. Next. Here's a picture of it. This is that long, empty suite we had. We took advantage of COVID, so we're in the back of the building. Dug a trench right along the floor drains. We knew we had a series of floor drains where the old dry cleaner was. And we're able to excavate down. These trenches were 4 feet max, practically speaking. That's about all you want to do, because it's from an OSHA limitation. Otherwise, you got to use shoring. You can see we had some setback from the walls. This was all based upon engineering designs. Concentrations in here are really, really high. We had to use extensive ventilation. We were really close to having to use self-contained or supplied air to operate. And then once we dug the trench, we lined it, put some piping, and backfilled the gravel. Next. We expanded this to the outside. The picture on the left, you can kind of see the cone there. That's the back door of that one suite we excavated. There's 4 SVE lines that came out of there. We also excavated on the outside. Just as a point of interest, we had a soil vapor point at a depth of 5 feet in this excavation. It came in at 13 million PCE, micrograms per cubic meter. So we had really, really high concentrations. All this soil went off as record hazardous. It was pretty stinky. And then on the right side, you can see this gang of pipes that we put in. A lot of piping, but once you have the trench open, get it set up. Again, looking on the left, we set up additional piping as reserve piping, because we knew we'd have to at some point go and establish more SVE within the building. This allowed us the flexibility. Next. So this is our SVE system. I'll just touch on this briefly. We're running 100 SCFM. We're permitted for 200. It's treated with 3 220 pound, basically 55-gallon drums of activated carbon. It's got a water separator before the blower, and we put this into a shipping container. I will go through the details of this a little bit more later. Next. All right, so what we do. So here's a drawing of the building, and you can see we dug in the middle. That Suite 100 is that long trench you saw in the pictures. So we put in 4 SVE lines in there. Again, that's a trench of maximum depth of 4 feet. The trench on the outside, we put additional lines out there, again, digging to 4 feet. Over time, we had an opportunity to get inside the building and do some additional work. But to date, we've recovered 2,000 pounds of PC as vapor. And most of that's coming out of this Suite 100 and the two trenches you saw. We've been operating for a few years, but we feel that these horizontal trenches have been really effective at PC recovery. And it also serves as mitigation too. So it depressurizes the slab and helps for indoor air. Next. So soil vapor extraction. Okay, we have a lot of lines. And I got a question. We're not going to do a poll question, but think about this. So why is the piping insulated? Okay, we've got piping on the roof, we've got piping on the wall, and we've insulated it. Well, next slide, please. The reason is that it collects condensation, okay? Soil moisture is fairly high in the ground. And these pipes, when they cool, will cause condensation or collect condensation. The water gets trapped, and the SVE is just not very effective. Point here is you can't see that unless you literally can see it. So install some clear PVC. Now, fellow I've been working with, David Drullo, has done this on many sites. And you can see examples from, these are a couple other project sites where tremendous amount of water is accumulated in the piping. Now, this is before the condensation or before the water separator. So this is just collecting in the pipe. And if you don't remove it, your SV is not going to work. Next. So it's a fairly well understood two-phase flow condition. If you go from right to left, and you can see this in the PVC. First, you get the little droplets, and then it goes to annular flow. You get a little, basically a little line of water along the outside. Then he starts getting bubbles of spurts of water, and then eventually it turns mostly water with spurts of air, and then it just turns into a bubbler. If you could go back one, I can show you that example again. So on the right, you can see the film. Okay, that's just a nice film. That's still running air. Going the next two examples, it's churning. There's air and water is bubbling along. And the one on the left is fully full of water, and it's just diffuse bubbles. So these really show you really good examples of these various two-phase flow conditions. Next. And next. All right, so soil vapor is permanently water. I did a real quick calculation here. Based on just 20 SCFM airflow, PC at 10,000 micrograms per cubic meter, which is generally considered to be pretty high concentration. That's pulling 8 grams a day, okay? Soil is moist, all right? So if you take it, just some basic assumptions, and you say, okay, let's look at a condition with a relative humidity at 90%, 65 degrees Fahrenheit. There's 1,000 times more water than there was PC. We get around 11,000 grams per day. It's about 3 gallons, okay? Dew point, it's a critical point. The critical consideration is dew point, what happens when you cool the pipe. And this is why we insulate the pipe. We're trying to prevent the air in the pipe from getting below the dew point. When the dew point hits, relative humidity is 100%, and the water condenses. And in this particular example, it occurs around 60 degrees Fahrenheit, and it starts to collect water. We see that on our site, and we deal with water on a weekly basis. There's no real good studies that David and I have looked at a lot of these sites, and we're just guessing at this point, and maybe your experience would vary, but a lot of this water is collecting, maybe even as much as 20% of it. It's a good topic for further discussion. Next. All right, so this is how we managed it. So this is our manifold system. Remember, there's quite a gang of pipes. Every one of our lines has clear PVC. You can see that in the middle of the left. We're using small diameter pipe. Okay, this is 1 1/4 inch pipe. You need a high velocity to clear the water. So what we do is we purge weekly. So what we'll do is we'll look in the pipe. If we see water, we'll isolate that line and basically suck out the water as best as we can. It runs into the knockout. Another point to be made here is do not slope the pipe and drain it back into the ground, okay? All you're going to do then, if you're collecting all this water, it's going to flow back into your SV extraction point, make the soil wet, and wet soil has a low air permeability. It just runs counter to what you're trying to do, which is to pull the water and the other vapors out of the ground. Next. All right, so our lessons here. So first of all, make sure to work with the people that really have hands-on experience at the building. The HVAC people, the plumbing, structural engineers, the excavation. I think it's hugely important to understand what's going on in the building as much as it's to understand what's going on in the subsurface. The people really control what's happening in terms of the VI conditions in the building. Going forward, keep these presumptive remedies in mind. SV and excavation and in situ remediation is going to be generally the path you're going to go. And then I'm going to go through and talk about some high resolution site characterization examples. Next. So as Andrew pointed out, over time we've gotten better at this. The high resolution techniques really are improving both how we understand a site and also helps explain and show in better, a lot of times, just better graphics to explain what's going on in the site. Next. So our subsurface investigation heavily relied on this high resolution. I'm going to show 3 examples. One is soil vapor. We have groundwater at 8 feet. So again, the VI condition is important because, or some of the groundwater condition is important to VI because you have PC dissolved in water, partitioning and causing a vapor phase. Historical point, and this is something that I saw early on in my academic career, was that soil vapor, soil gas surveys were originally developed to map VOCs and groundwater. This is before anybody really cared about vapor intrusion. They were designed to map groundwater, so they're really helpful for that, especially if you have shallow groundwater conditions. Second one I want to talk about is some groundwater profiling we use to assess our geochemical conditions and hydrologic conditions. And the third, I'm going to go through and talk about the membrane interface hydraulic pressure tool. Okay, this is a really excellent methodology. Again, this is something Andrew touched on. As you collect these data, you're going to continually evolve in terms of your site understanding. The conceptual model really doesn't stop. Potentially, in terms of writing things up, it does look like it's episodic, but as you get data, you learn more about the site, and you're going to get a better understanding of what you're going to do. Again, I want to make, I think a big point here is that the subsurface is not the whole story. A lot of us are geologists. We worry about the soil and the groundwater and all this stuff, but the building operational characteristics are probably as important, and maybe in some cases more important, than what we're talking about in terms of considering what's going on in the subsurface. Next. So first example, soil vapor. This is something that Andrew touched on. You got 2 options. One is traditional, called active soil vapor. You stick a probe at typically 5, 10, 15 feet, test it, remove it. It's fairly slow and it's fairly expensive. The passive methodology, which is what we used here and worked really well, you can see the example on the right. You get these 2-inch diameter tubes, metal tubes, about 2-inch by 12 inches. Put them in the ground, drill a hole a little deeper to get some vapor moving in it, and you put a sorbent media in this. Now, these sorbent media, they go in the ground, they sit for maybe a week, maybe 2. And the state of the science has evolved to the point now that these concentrations from the sorbent media can be converted to vapor concentrations. Next. So here's an example. The results come back and they actually speciate. So this is for PC. This is our dry cleaner. Now I apologize. Generally we've been drawing the drawings to fit on the page. So this is actually oriented north, so the building's turned a little bit. But you can see this bullseye, and you can see pretty much where our dry cleaners were. There's a hole in the middle because we didn't have access, but essentially it created a very good bullseye. 2 points here. One, this is logarithmic contours. It drops off fairly quickly. Concentrations that we see here, the higher red, are under 500,000 micrograms cubic meter. That's pretty close. That's similar to what we were seeing later when we came in and put the soil vapor probes. The second is, this took us 2 phases. And it's good. It took us some time, but we did the first phase and said, whoop, we got to keep going. But the nice thing about it is, if you notice, most of these points were done inside the building. It just takes a rotor hammer and a few minutes to install these points, and we're able to do it fairly quickly. It was not, we're working around people. All these suites are occupied. The businesses are occupied. So you go in early in the morning, put them in, and nobody knows you were there. And we do recognize that at this point, these data are not usable for quantitative risk assessment, but they're really useful for, 1, seeing what the plume looks like, getting an idea what we're doing, and 2, for optimizing the next vapor monitoring points. This allows us to put a lot less points in the ground, which over time are really expensive because you're coming back and sampling quarterly or semi-annually, and it just, there's a exponential cost every time you put a hard sampling point in the ground. Next. So here's two more examples. Here's TCE, again, it's speciates. Again, we got red concentrations. Again, we're still in the order of 100,000 TCE. Now, for just to remind everybody, so TCE is the primary degradation product of PCE. So this is forming in response to the, in this case, generally the biotic degradation of the PCE. And then on the right is just their total HVOCs, the PCE plus all its degradation products, the trichlor, the dichlors, and the monochlor. So that gives us an idea what the overall plume looks like. It did show us it's a little bigger than we thought. So we have our hands full here, but it does give us a really clear idea of what's going on in the ground. Next. So I want to touch on this quickly. This is in situ geochemical profiling. I'm calling this high resolution. I haven't really seen this done elsewhere. I just wanted to throw this out here. So when you do low flow sampling of a well, you usually set up a flow cell and you run the water through it and you measure temperature, electrical conductivity, dissolved oxygen, redox pH. You wait for it to stabilize before you take your sample. You can take this same tool, put it on a cable and drop it down a well. And this is what we did. And this gives us profiles and understanding of all these parameters in the ground every time we've done sampling. And what we do is you go in and you do this under static conditions. You work with the ambient groundwater flow conditions. You use undisturbed well condition, and you just really slowly lower this probe down and take samples or take measurements, and you get a lot of data. And I'll show you what it looks like. Next. So here's an example of one of the times we ran it. And this is the ORP. This is the oxidation reduction potential. It tells us if it's aerobic or anaerobic conditions, essentially. And it shows you we had a wide variety of conditions. We have, back to the conceptual model, we had the shallow aquifer condition, and we had a deeper zone. So our shallow wells are targeting this shallow unconfined aquifer, and the deeper wells are targeting the zone down basically below that clay sand, because the clay sand is basically impermeable. So there's not a whole lot of use in putting wells in it. So you can see that it really gave us a lot of data. And we've used this to our advantage going forward to see how conditions have changed. We've gone to in situ chemical reduction for our groundwater remedy, and we've been using these data to show, to attest it to see how much reaction we're getting. Next. Another parameter which is really quite useful, especially when you got a variety of groundwater types, is just looking at the electrical conductivity. It comes back, it can be presented in terms of TDS. Here we got a factor of 10 across the site, and it's been very important because we're dealing with what I call urban hydrology. There's a lot of different influences, different causes of water into the ground, and this really helps us sort things out. And it also helps show that we had this really sharp saline water interface at depth. So I just want to leave it at that. It's a really useful tool. It's cheap and it's quick. And it's a really good way to try to assess what your groundwater conditions are with depth and laterally. Next. Okay, so I want to close out with the membrane interface hydraulic pressure tool. Now, this is a really good tool. I would say up front that without this, we really couldn't have done the work we did. It really helped a lot. We did it in 2 phases. We worked inside and around all these active buildings. The tool provides basically 3 types of data. One is in situ VOC profiles. Second, hydraulic conductivity. It tries to squirt water into the ground and measures the pressure and the flow, so it gives you an idea of the hydraulic conductivity. And then it's got a little electrode array, which is a geophysical methodology for getting electrical conductivity of the formation. So it's a function of porosity, electrical conductivity to the fluid EC, and some of the clay content. It gives us really precise vertical resolution and high quality data. And it's vastly superior to core logging and sample analysis. It just simply provides data you just can't get otherwise. Next. So here's a quick schematic of it. Again, it has a hydraulic pressure tool. So what it does is it tries to squirt water into the ground. And runs up to about 110 psi. So it measures the pressure and flow. So it gives you, so it can calculate hydraulic conductivity. The membrane is a heater. So it's a heating pad. It boils off the water. And as it boils it off, creates a vapor. It has nitrogen carrier gas, sweeps that back, and runs into a series of analytical machines. There's 4 of them. If you're a chemist, you'll love all this stuff. If you're just me and you're just trying to use it, what we really relied on here was the halogen-specific detector, which is called the XSD. It responds to the halogenated compounds, the PC, TC, DC. And this is really one we relied on. It also has a PID, which is the same thing we're using when we're sniffing around the building. And it also has a flame ionization detector. This is actually, it used to be an old school field methodology, but it responds to all the combustibles. And it also does electrical conductivity. So it gives us kind of a lithologic log. It's a very well-built tool. It's been used, oh gosh, I'm guessing now easily 10 years now. So it's well developed. It's complicated, so you got to get a good contractor to get good results. Next. So I'm going to go through this and explain what we were able to do with this. So again, here's the conceptual model on the right. Again, just to remind everybody. So you got groundwater at 8 feet. You got this little thin lens of unconfined aquifer. You got this clay sand, this low permeability clay sand, and some deeper material. So we're able to use these data to actually map these surfaces. So the surfaces that we're going to focus on is the top of the clay sand, the base of the clay sand, and the saltwater interface, trying to get a quick idea of what's going on. Next. So this is what we did. We used the soil gas data, so the passive soil gas data to kind of target and design what we did, plus access. I mean, it's really hard to run these tools inside the building. You need a dolly-based LAR rig. It's tricky, plus you're on a cable, so it's logistically it's quite a challenge, but it's worth the effort. We did 41 borings, maximum depth about 36 feet. Next. So here's what it looks like. You use a direct push rig. There's the operator. So that tool's on the bottom of the direct push. And there's a cable that runs back to the truck that's carrying it's a tube with the nitrogen sweep gas that picks up the volatiles. And it also has all the electrical connections for all the instrumentation. On the left, you get a sense of what you see in the truck. The logs all come out real time. You got 4 analytical machines working. You got the hydraulic pressure tool working, and you have electrical conductivity. So you're getting, in this case, you got basically 6 panels reading out at all times. It's pretty interesting because you can get a sense of really what's going on in real time. And if you put it in the terms of the conceptual site model, you're learning a lot every day. So it's been a great tool. Next. So I'm going to give you an example. This is actually the first boring we put in with the MHPP. And this is really was an eye opener. I really started to see things that we really, again, this site had been worked on for decades, and it wasn't until this MHPT survey they really started, things really came into focus. Next. So this is a detail. I want to walk you through this. So going on the far left, the green trace is the pressure. So this is the pressure that this water is trying to squirt into the ground. As you go down with depth, you can see about 8 feet. We hit groundwater. We started to see a little more pressure, and then boom, at about 11 feet, it maxed out. We hit this low permeability clay, and it just stuck there. It just would not flow for, in this case, for almost another 15, 20 feet. And then we started seeing some flow at depth. Next one over is electrical conductivity. It's kind of a logging tool. It's a traditional logging tool. Really, it's one of the earliest methodologies used for oil and gas exploration. It shows us it's pretty featureless. So this tells us there wasn't a whole lot going on internally to this clay sand. Most of the activity is on either side of it. The right panel on the left side is the blue line. This shows us the calculated estimated hydraulic conductivity. It shows we got some moderate permeabilities in this shallow unconfined zone. nothing going in the clay sand. And then we started picking up some permeability with depth. So the flow was so low that there was no resolution. It just couldn't do any calculations of it because, again, this clay sand has no permeability to speak of, very low. To the right, here our probe. Here's our instruments with depth. I want to focus on the red line and the second from the right. This was the XSD, which is the halogen specific. The dotted line at 500,000 is what we call a rule of thumb. So Cascade, who we worked with on this, they've done a lot of this. And what they say is that basically above that line, this is where we start to see DNAPL. We think there's free phase PC in the soil. So if you look at the gray lines that are highlighted, every time it exceeded, we're going down in this with depth, and we're seeing, oh, we got DNAPL at 10. And this is real time. So we're looking at it, go, oh, we got some more at 14. Oh, we got some more at 16, 18, 20, 22. It's like, wow, there's a lot of DNAPL here. And it was a lot compared to what they've seen in a lot of other sites. The other instruments are also going off. Those are the ones on the right. Again, they just confirmed that we're sitting there looking at zones that are high concentrations of PC. Now, keep in mind, this is just where it intercepts. This is not giving us horizontal layers. This is just the intercept of that boring. Next. So here's an example we're able to do. We're able to take the top of the clay sand. This is what forms the base of this little thin aquifer we have. And we're able to make a really good map of the thickness and extent of this. Again, we're looking at VI. I don't want to lose the focus here. The VI condition here is that we have contaminant dissolved in groundwater, partitioning back and causing vapor phase. So this shallow unconfined aquifer is really a transport mechanism for a lot of the vapor intrusion. So it's really important, but it just gives you a sense of the level of detail you can get with this. You just could not do this with traditional logging. Even if you continuously cord it, you still wouldn't get this type of data. Next. So let's go to 3D. So these are the borings. This is kind of looking to the north. You can see the PC soil vapor map on the top. Our red is our source area. The colors indicate where we had high responses. Again, we're going to focus on the halogen specific, the XSD tool. Okay, so this is our boring map. Next. Okay, so now we're able to pick off the tops. And so the red's the top of the clay sand. The next one's the basis clay sand, and the blue one is the top of the saline layer. So again, this is the conceptual model. Now it's gotten better in 3D, and it's hopefully to you looking at this gives you a better idea what's going on. Next. So now we're able to then take this expert rule. Anything that was over 200,000 microvolts in XSD is where we suspect that we have PC. So you can see the purple guy. We call him Barney. So Barney is the main part of our PC release, and it makes sense. Barney's pretty much underneath the above ground storage tank and some of the dry clean machines. So it gives us an idea of the extent. Now, it's not fully saturated, but it tells us kind of the envelope from which that we can look at. And, over time, again, we're looking at VI. The concern here is that, if Barney keeps bleeding off, it's going to continue to contribute to groundwater, which it can contribute to vapor phase, which will contribute to the indoor air problem. So this became another element that we really have to address on our remediation side. Next. Hydraulic conductivity. So the dark is that clay sand. The bars here, actually I should have pushed it down more, but it's on the order of 10 to the minus 5 centimeters per second, really low permeability. Gives you a real clear idea of what's going on here again. So you can see that we have this restrictive layer, got some more permeable sections down below. And these diagrams you can spin and flip and look at in 3 dimensions. It's if I had time, you could have seen a whole bunch of interesting slides and movies. So What I want to do now is just kind of go through and use the XSD to give an idea how the plume evolved over time. Next. So the highest XSD, greater than 500,000, we saw that in that one boring. That was, excuse me, where a lot of that was. So this is the highest concentration. And now I'm going to roll through and decrease the sensitivity of the machine to start saying, okay, where are we getting from not only PC free phase, but the dissolve phase. So this is the first, the highest portion, the highest concentration within our buddy Barney. Next. Now you can see Barney is about 200,000. So this is the envelope that we think that we have most of the free phase. Next. Now we're starting to get out in the dissolve phase. You know, it makes sense. We have the free phase starts to dissolve, creates a dissolve plume. Next. Get to about 50,000. This put in the red here, just to give you a sense of where we're at. This is the top of the clay sand. Material got down into it and it's spread out to a certain degree. Next. Now this is the same blob, but now we're looking at the basic clay sand and the saline liner. So we're getting a pretty good sense of how this plume has evolved over time. And again, this is decades. So, this release ended 25 years ago. So these data are telling us what happened up for the last 25 years since the release. Next. So here's the last picture of this. So you get a sense looking at a direction. We have Barney. Barney's head is pretty much a release area. It got into this clay sand and pretty much stuck, and some of it got out. So it gives us a real clear idea of how we could take that initial conceptual site model and put it in three-dimensional view. Next. So the results really helped us a lot. It clearly helped map out the vertical and lateral extent of the HVOCs. We can clearly see the DNAPL release in the source area. It allowed us to collect a lot of data without tremendous lab expense. I mean, the analytical burden of trying to do this with continuous coring and sampling would be tremendous. One point here, we got kind of a lucky location from two regards. One is non-beneficial groundwater use, but the other was that the low permeability conditions have limited the DNAPL mobility. So that's, so in some respects, if it had not been for this low permeability material, who knows how big this plume would have been. Next. So we can actually take some of these data and we're able to analyze how much DNAPL saturation and mass is in there. So we're able to take the XSD data and compare it with soil concentration data. And what we found, the take home on this, is that the residual saturation in terms of how much PC is in as a percentage of the pore space was really quite low. It's 0.01 to 0.03. Doesn't mean a lot of mass, but it just tells us that it was fairly low, which kind of makes sense because it's an old release, a lot of soapy wastewater. And then we could take that estimation to come up with a volume calculation of how much is in the ground. Next. So here's a map that shows the red shows the soil vapor, the green shows MHPT data. It's interesting. These two were not exactly the same. The reason for this really is that as the release got into this upper unconfined zone, it started to spread out, but where it didn't, it went straight down. So there's kind of a juxtaposition of the surface versus the deeper expression, which really was important in terms of going forth with remediation. Next. So if you take the logs and just start playing around with the data, you look at the XSD response in terms of various thresholds, you can get a sense of how much is in the ground and how intermittent it actually is observed. So two borings dominated. This M15, which is the first one I showed you, and there was one next to it, M16, where most of the highest concentrations were located. But you screen those out in the middle panel, and you look at the XSD about 150,000 to increase the threshold a little bit, you get a sense of where we're seeing little stringers of high concentrations of PC. Now, again, this is not vertical. This is just where it intercepts, and this is how the histogram works. And then on the right panel, we can show that, where the highest stuff is. A lot of it was just this M15. M15 was located just about 3 or 4 feet away from the above ground storage tank. Next. Okay, so the top. So we just run through some numbers here. So if you look at PC saturation and compare it to what theoretical mass concentration would be, concentration by mass, saturation of 0.01 gives us a result of about 2.25 million micrograms per kilogram. 0.03 runs it up to about 6.7. We compare that to our soils data. The maximum we ever saw, and we do have a lot of soils data, was the maximum was about 7.3 million. So that tells us these bounds, the upper bound and lower bound, are probably reasonable, that we are looking at residual saturations about 0.01 to 0.03. So if you do a very simple cylindrical assumption of area and mass and whatever, and use these percentages, if we look at the interior, which we call 500,000 and greater XSD response, we get about 0.03%, you use a 0.03 for that area, and then exterior, use a 0.01. We came up with about almost 14,000 pounds of PC. So this really helped us refine what we have in terms of the total mass. And also tells us we had a pretty big problem. Next. So again, the benefits of this, and this Andrew touched on quite a bit, is that these high resolution data are basically essential. We could not have done this without this HRSC. It really does help. The folks we're working with here at the local water board really appreciated these visualizations, and it really helps explain what's going on. And it does help focus everything on going forward in terms of what we're going to do for remediation. Next. And here's just to give a quick benefit. This is our injection design. Again, it was just completely based on the high resolution data. It really supported it. And then we're also using these groundwater profiles to monitor the progress. Next. So that in closing, this data was critical. We couldn't have done, excuse me, we couldn't have done it without it. And that M15 example, it really fundamentally changed how we looked at the site and what we were going to do for remediation. It really opened up our eyes. The passive soil gas is very efficient, really helpful, and helps us put in later designs for vapor pins and fixed points. And in summary, this early investment really improved how we understood the site, conceptual site model, and truly reduced the uncertainty. And the bottom line of this, it probably saved us hundreds of thousands of dollars on the remediation side. Next. All right, so now I'd like to introduce Saru, who's going to give you a quick update on how this looks from her perspective. This is the SCAP project, and she'll tell you all about it. Thank you for your time.
So I'm Saraswati Paudel-Acharya. I go by Saru. I am Water Resource Control Engineer here at State Water Resource Control Board. Great job, Jay. I really appreciate you so much for presenting the case study in today's workshop. Hopefully, there were some really good takeaways from the case study. So the Site Cleanup Sub-Account Program is a funding program established by the legislation, Senate Bill 445, and written into a Health and Safety Code in 2014, which allows the State Water Board to issue grants for reasonable and necessary cost associated with projects that investigate and remediate the source of surface and groundwater contamination. Next slide, please. So this slide shows the typical scope of work that SCAP developed to address a site contaminated with volatile organic compound. We came up with this roadmap around 2021-22. The tasks are site-specific, of course, and depend on how much data that are available for a particular site during the scope of work development phase. Like Jay mentioned, so SCAP addresses the site with a detailed site investigation that includes various high-resolution site characterization, including passive, soil vapor sampling, and MIHPD. So the site investigation kind of builds up the preliminary and baseline CSM, while the CSM matures into design and remediation stage during the IRM phase. And finally, the monitoring program captures the post-remedy CSM to prove that the cleanup worked and the contamination levels are staying below the risk. So again, preliminary design phase and a post-remedy CSM, I want to emphasize on that. Next slide, please. So for this particular project that Jay presented, this project received grant 1 and grant 2. Grant 1 was from 2022, June of 2023, and then grant 2 is ongoing. It will expire in June of 2028. Like Jay mentioned and then presented, developing a robust CSM during the site investigation phase and performing the targeted remediation while addressing the vapor intrusion is the goal of SCAP for the site. So site investigation in grant 2 kind of addresses what we have found as a data gap identified in grant 1. For the IRM in grant 1, we did some pilot testing of a soil vapor extraction system, and then IRM in grant 2 included the excavation that Jay showed the pictures of. And then we are ongoing remediation of groundwater right now, and of course, optimization and continuation of soil vapor extraction system that is currently running at the site. Next slide, please. Here, I want to kind of address with different media. So delineation of shallow soil vapor was addressed with the passive data, which is again one of the HRSC that Jay presented. Source identification was done with the help of this tool, and soil vapor extraction system currently running at the site is addressing the VI risk from soil gas. Removing PCE from beneath the ground will help lower the contamination in indoor air. So again, the groundwater is very shallow. We perform 24 days of in situ injections with GBI and some biogeochemical reduction solution. And then right now, monitoring a report of waste discharge is being done. The preliminary groundwater already shows the 200-fold decrease in concentration in groundwater. And then the VI mitigation was done with the quick fixes that included installation of vent and exhaust fan on the roof of the building and repairing the HVAC units for the building. As a result of SV system and the quick fixes that were done throughout the duration of the project and ongoing, level of PCE in indoor air declined significantly with overall HI index of less than 1. Reducing the level of PCE in indoor air helped the people working on the on-site building breathe the cleaner air. Next slide, please. With that, I'm going to close by saying, as we all understand that a robust CSM serves as a data-driven decision support system rather than just a summary of what has been done at the site. By synthesizing this complex data into maps, cross-sections, or flow diagrams, a CSM helps project managers reduce uncertainty, lower long-term cost by predicting unforeseen problems, and communicate risks clearly to regulators and the public. The CSM of a site is never finished until a site is closed, as we all know, kind of mentioned multiple times today already. It is constantly updated with new data to ensure that project stays in track and it is cost effective. With that, thank you everyone, and next slide, please.
All right. Thank you so much. Jay and Saru will now take 15 minutes for Q&A for the first case study. So thank you all for the questions that you've been putting in the Q&A so far. Our work group members are busy at work providing answers to that. As a reminder, you can also use the raise hand feature to ask your question verbally. So just real quick, for those joining by phone today, please press *9 to raise your hand and *6 to unmute yourself when prompted. Since we have so many attendees, we do ask that you ask one question at a time, and I'll be switching back and forth between the Q&A window and raised hands. I'll go to the raised hands first. So if I do call on you to unmute yourself, please state your first and last name and your affiliation before you ask your question or give your comment. All right, with that, I'll go ahead and go to the hands. So I have one hand up. Cheryl Carey, you should be able to unmute yourself. Cheryl, are you there? Give it one more second. Okay, not a problem. Go ahead, Cheryl. I saw that you just put your hand down. Not a problem. Thank you so much. And so with that, there's no other hands raised at this moment, so I'll go to the Q&A. So the first one up here was, hi Jay, which handheld PID system are you using that is sufficiently sensitive to meet agency risk screening levels? So there's a couple parts in that question. And I'll actually go to our CalEPA member Cheryl Prowl to assist with answering this one. And then Jay, maybe you can touch on the handheld PID system. Cheryl, are you available?
Yeah, thanks, Julie. So I do want to hear from Jay about which instrument he actually used, but I want to touch on the fact that the screening with a PID is for multiple data quality objectives, or DQOs, and Andrew talked about that in his part of the presentation, that there's often an investigation, multiple questions that we're asking. Is there a risk is a really important question, but if there is a risk and you know that, then the handheld PIDs can be a really useful tool for understanding how are vapors coming into a building? Is the exposure pathway complete? And knowing where vapors are coming in is really important for understanding how to start mitigating the vapors and how to stop the actual exposure. So yes, understanding risk is important, but don't lose sight of all those other data quality objectives. Okay, Jay, do you want to talk about which instruments you use?
Yeah, it was they call it a PBB RAE, RAE instruments. It's capable down to parts per billion measurements. And then getting back to the risk assessment side of it, it really wasn't intended to do anything from the quantitative risk assessment. We rely on analytics for that. SUMICANs or that type of instrumentation or type of data collection. It's really a screening tool. And in our case, we have such grossly high concentrations that it doesn't take much to find it. Now, at a PPB level, you are going to find most of what you call the vapor conduits or points of entry. So it really was to do a building reconnaissance to look at the drains, look at the cracks, try to get a good sense of where the problems are occurring. And then once we identify that, then we go next level. Then we'll come in and we'll do the indoor air sampling with maybe a SUMICAN or even continuous air. But at this point, the concentrations are really fairly high. But even at a PPB level, you can detect quite a bit.
Great. Thanks very much, Cheryl and Jay. All right, moving on to the next question. It looks like a non or semi-permeable geofabric is in the trenches, and that because of that, the focus is more on removing PCE from the building rather than conducting SVE. Just wondering if that was the intent. And that one's for Jay.
It was a MIRAFI filter fabric. It has air permeability, so it was quite good at passing vapor through it. So it was air permeable. It may look like a plastic, but no, it's a very permeable fabric. And the long trench that you saw is primarily where we were getting our vapor recovery. And so just guessing, we've probably pulled close to 1,500 pounds of solvent from the soil from that trench. So it's working as a remediation. It's secondarily for mitigation.
Great. Thank you, Jay. All right, next up, we do have a hand. Nadine Weinberg, I'll go ahead and click. You should be able to unmute yourself. And again, please just share your name and your affiliation.
Hi, thank you, Julie. This is Nadine Weinberg, and I'm with ERM. I actually have a question for Andrew on the first presentation. Is that okay to ask?
Yeah, I think that's okay to
Okay.
ask right now.
Great. So I thought I heard him say that the multiple lines of evidence cannot be used to justify sort of use of an alternative attenuation factor. So I just wanted to get clarity if that is the case, and if so, what are the other methods the state recommends for coming up with alternative attenuation factors for a site?
So no, I was not saying that you cannot use it for that purpose. I specifically said yes, it can be used for that purpose. It's just, using the MLE approach is far more reaching than just attenuation factor. And it seems like in California, especially, we've gotten stuck on that. So I wanted to really stress the point that we should be using the MLE approach throughout the entire life cycle of a project.
Okay, so you can use it for an attenuation effect, but it has broader use.
Exactly. It's not the only.
Okay,
It's not the only application. Yeah.
Okay, great. Thank you.
Welcome.
Excellent. Thank you so much, Nadine and Andrew. All right, next up is going back to the Q&A. We have a question of, if we are beginning a soil vapor program, should we be checking with the grant to SCAP to see if we qualify for funds? Saru, are you able to unmute yourself and talk to that?
Yeah, of course. Yeah, please reach out to SCAP. I can drop in my email address here, and then we can go from there regarding the qualifying for the funding. Absolutely. Please contact us. Thank you.
Great. Thanks, Saru. All right, the next one up is a question. It looks like this is for Jay. Excellent case study. If you're willing to share the rough cost estimates for investigation and HRSC interim remedies and remediation would be helpful.
It's expensive, as all these sites are. Let me try to break it down. It might be helpful. So we look at the passive soil gas. That's fairly cost effective. That's a couple $100 a point. So I think we were, oh gosh, I don't have the numbers in front of me. I'm just giving a rough number, but I think we're able to do the passive for on the order of, let's see, 180 points. On the order of about $20,000 for the whole site. Keep in mind, it's a lot of it's logistics. If you have an easier site, you can go a lot quicker. The MIHPT survey was, let's see, 41 borings. That was on the order of about probably $25,000 to $50,000. Probably close. No, I'm sorry. It's probably closer to 75,000. It could be higher. I'm sorry, I don't have the numbers in front of me. But if you compare that to the actual drilling costs, if you went in there and tried to do continuous scoring, sampling, analytical, it'd be 5-10 times that much. So really cost effective from that perspective. Are there any other components you want to look at? But I mean, the overall budget, first phase was in the order of a little over $1 million. In the second phase, we've got, we're probably spending, from the remediation standpoint, we're probably in the $700,000 to $900,000 range for remediation. So, it's expensive, but we also are dealing with an awful lot of PC in the ground.
Great. Thank you so much, Jay. Okay, next up, we've got another in the Q&A, and it's asking, what was the material used to insulate the vapor extraction conveyance pipes that are above ground and in the sun?
It's a common material. You can get it from a number of industrial suppliers. It's a hard foam. It is a little tough. It's not UV protected, but it seems to be lasting 3 or 4 years so far. We may need to replace it at some point, but and I can't recall offhand what supplier we got, but it's a pretty common industrial product.
Great, thank you so much. Okay, we do have another hand raised. I'll go over to the hands. All right, Mark Boland, you should be able to unmute yourself. Go ahead and share your name and affiliation.
Thanks. Hey, Julie. Mark Boland, ERM. During Andrew's conversation, I think he was saying a few things that I would have helped with a little bit more information. I think he was saying that you could use the lines of evidence to determine if you had enough data to evaluate the temporal changes and trends. Could you clarify what some of the best ways that you have seen or work best for your decision processes to determine if enough data has been achieved to evaluate those temporal changes?
Yeah, great question, Mark. Andrew, are you available? And this can also, I invite others from the CalEPA group, and Jay also, if you have some thoughts, please go ahead and share. And so again, I'll go ahead and there's Andrew.
Sorry, I was typing a response to another question.
No problem. Go for it.
So you'd like to know what lines of evidence I've seen for temporal changes
have been most effective in your opinion? Yes.
I mean, multiple rounds, seasonal variability. Making sure that you're and not just temporal, but looking at both temporal and spatial. So making sure that you have your locations in the right spots, plural. And then again, collecting enough rounds of data. Honestly, it's just the simplest way that I've seen. I don't know if anyone else wants to chime in here.
Hey, Andrew, I'll chime in. Hey, Mark, thanks for your question.
Hey, Jen.
Hey, so for when it starts coming to temporal data, I think it's obviously going to be site specific, right? First.
Yeah.
And then I think the most important thing too is checking the variability of your data, right? So the reason why we ask for that temporal data, especially with like buildings, we want to see how the HVAC is, working or influencing. So if you're seeing significant differences between the data sets, let's say of a cold month and a warm month, or a rainy season versus a dry season, more additional data may need to be collected, right? Because then you're really just looking at one point because they're two different populations. So I think the biggest thing is it's site dependent, and it's also based on what your data is saying. I hope that helps clarify.
It does. It's just been one of those ongoing discussions about, and agreed, it always is site specific and condition specific, but seeing when is enough data enough, and my experience personally has been it kind of also varies on the caseworker.
Thank you, Mark.
Yeah,
thanks, Mark.
Just to follow up, and that's something that we are trying to work on here, is making sure that everyone has the same understanding. All the regulators, whatever branch of CalEPA you're under, have the same understanding and are looking at the data in a similar manner to consultants and RPs. So that is something we are working on. But again, and I know it's already been said, but site by site, right? Every case is different.
Of course.
And I think that although we all acknowledge that, we all understand that as a concept, I think it's hard to get away from wanting a simple answer to something, wanting a prescriptive method. But at the end of the day, there is no prescriptive method. And I think that's why we're trying to take this approach.
Thanks, Andrew. Jay, go ahead.
Yeah, hey, Mark, just wanted to add a little to that. So you're looking at two things. One is time scale and the other is resolution. So if you're looking at seasonal versus diurnal changes is important. Methodologies can vary. We traditionally have been using 8-hour averaging on SUMICANs, which give us a number, but it doesn't really tell us what's going on, say, from an operational perspective. There are methods. There's a fellow by the name of Blaine Hartman who's been doing a lot of work with on-site work, where basically it's real-time GCMS, where you can get, it basically puts a whole series of tubing in the building, and you can get real-time data in the building. That's really diagnostic. Again, it's coming back to the resolution question. At what level do you need that? And what we found on a lot of these sites is that really getting a good handle on the HVAC system is probably as important, and the people. All right. And this is a point that, if you hear Blaine's talks, it's obvious. I mean, it's the people. What are they doing? Do they have doors open? They have, what are they doing? What are they working in the building? So you can get all the data you want, but if you don't have a clear idea of what's happening in the building, you really can't interpret it. So, but they go hand in hand. But the time frame matters too. If you're looking about seasonal, the soil vapor data can give you a pretty good handle on it. If you're looking at short-term temporal, you got to go indoors and look at real-time data. So that's all I got.
Thanks very much, Jay. And Barbara, I do see that you might have something to add. I just want to note we're almost done with our 15 minutes here. So please go ahead and share.
Yeah, thank you. This is the reason for this workshop, Mark. Every site is different, and I can just say from a risk assessment perspective, just ditto what everyone else just said, especially Jen and Jay about just the temporal variability. But as a risk assessor, we're also looking at into the future and how site conditions might change, and that how risk might change. You might have the same indoor air concentrations, but we also consider all those other lines of evidence, and that's why this holistic approach and looking at more of these qualitative methods that can give us more information about what is the residual mass under a building. Is it a large mass that's going to be emitting vapors for a very long time, or is it a relatively small mass that we think can be mitigated and remediated over a nearer term? So that's what we're getting at this workshop, is trying to extend our view to some of these other tools that'll give us really important qualitative information that we can use to support our risk-based decisions. Thank you. Really good question.
All right.
Thank you.
Thanks very much, Barbara, and everyone else. Okay, so that does bring us to the end of this first 15-minute Q&A. I know that there's at least one other hand and another question in the chat, but we will get to those at the end of the workshop in our 30-minute Q&A session. So thank you all for the questions. Go ahead, next slide, please. And so now I'll go ahead and pass it to Jessica Law to present the second case study. To you, Jessica.
Thanks, Julie. So I'm Jessica Law, Senior Engineering Geologist with the Santa Ana Water Board. Next slide, please. So today's presentation, I'm going to talk about just briefly the site background, discuss components of the vapor intrusion investigation, briefly touch on the public outreach efforts for this site. Then I'm going to go over 4 residential vapor intrusion scenarios that have been encountered, just so we can walk through how we've utilized multiple lines of evidence, and then close with some best practices for successful vapor intrusion investigation. Next slide, please. So the site is located in Southern California in Orange County, and it's about 2 miles from the Pacific Ocean. It is outlined in black on this figure. Next slide, please. The site is a former aerospace research and development facility located on approximately 98 acres, and it is outlined in black on the figure on the right. The site was remediated back in the 90s and received a soil-only closure in 1997. However, there was the requirement for continued groundwater assessment and remediation. The primary contaminants of concern are PCE and TCE, and depth to groundwater is approximately 50 feet at the site. However, as the groundwater plume extends off-site, depth to groundwater gets as shallow as 8 feet below ground surface in certain offsite areas. I do want to highlight that there are 2 offsite investigation areas of interest, and that's because the site groundwater leaves the site in 2 directions. It goes to the north as well as to the south. So when I refer to the site, this does include the offsite areas as well. And there are several unique features associated with the site. So a complete CSM has been critical to the understanding of the contaminant transport and ensuring an adequate evaluation of vapor intrusion. And I'm going to touch on some of those features later. Next slide, please. So this site is one of those with a long history. The facility operated from the late 50s into the early 90s. When operations ceased, the facility was demolished and environmental investigation and remediation was conducted. Then in 1997, 96-ish timeframe, the site received a soil-only closure. And this allowed the site to be rezoned from industrial use to residential use. And redevelopment began shortly after that. That's when the primary focus shifted on impacted groundwater offsite. Now, over the years, there's been advances in science, the changes in regulatory screening levels. The EPA published the TCE action levels in 2014, and the environmental screening levels were updated accordingly in 2016. So in 2017, the Santa Ana Water Board requested an updated conceptual site model for the site. It was the updated CSM that had reevaluated the historical data and identified the need to evaluate the site for vapor intrusion, and the vapor intrusion investigation began in 2018. Next slide, please. Now, since one of the site's contaminants of concern is TCE with those short-term exposure risks, as a regulator, we wanted to ensure a complete vapor intrusion investigation path forward was laid out prior to beginning the investigation. This allowed for an adaptive process, making data-driven decisions. Therefore, decision flowcharts were included within the work plan, and they were prepared for both residential and commercial properties. Now, this allowed the investigation to continually move forward without requiring extra steps. They were already anticipated and laid out. And this resulted in simple addendums being submitted and approved to document if additional probes were being installed or additional homes being included in the indoor air testing area. Now, there were 3 main paths that were anticipated, and they included the first was the initial steps regarding the soil gas assessment and delineating the plume to non-detect, which is the left portion of this flowchart. And that is basically step 2A of the supplemental guidance. And I will add that a link to the 2023 supplemental vapor intrusion guidance is being added to the chat for your reference. The next section in the center outlines the next steps based on the soil gas results, prioritizing homes that should be evaluated first based on short-term exposure risks, as well as evaluating temporal variability, which are steps 2B and 2C of the supplemental guidance. And the right portion of the flowchart outlines indoor air sampling and the next steps based on indoor air results, which also includes timeframes for when those next steps should occur, from implementing mitigation measures to conducting temporal sampling for evaluating current risk, which are steps 3 and 4 of the supplemental guidance. Now, the decision flowchart was developed with relevant vapor intrusion guidance documents and screening levels, considering both short and long-term health risks. And it is important to mention that all of the work has been done in a phased approach. As analytical data was received, decisions were then made based on the path forward laid out by these decision flowcharts, which allowed us to prioritize efforts where VOC concentrations were highest. Now, I will also add in the beginning part of the supplemental vapor intrusion guidance, there's a flow chart that outlines the 4-step process. So it shows you where you can skip from step 1 to step 3 or going step 2 to 3 to 4 as appropriate based on site-specific information. Next slide, please. So now I would like to discuss some of the details of the investigation. It's a busy slide, a lot of information, but I do want to use the investigation summaries and this figure on the right to explain the magnitude of the investigation. So first, just to kind of give an idea of size. At the center of the figure is the former facility. It's outlined in blue. That is 98 acres in size. The shaded area is located at the central to northern portion of the figure, and that shaded area south of the former facility, this represents properties where buildings should be evaluated for vapor intrusion based on soil gas exceedances. Green would be residential properties and blue is commercial. Now, that main soil gas plume located at the center part of the former facility, which extends to the north-northeast, is about 1 mile to 1.5 miles in length and 0.5 mile wide. The smaller plume at the southwestern area of the figure is approximately 1,100 feet in length and 200 feet wide. Now, I mentioned a few slides back about the site having some unique features that contribute to the contaminant transport. One of those items are the historical arroyos, which groundwater impacts tend to follow. The large soil vapor plume mimics the groundwater plume, which follows one of these arroyos, while the southern groundwater plume follows one of the buried arroyos. There's not a soil vapor plume associated with it. It was discovered that contaminated groundwater also leaves the southern section in another direction not previously identified. And it was the soil vapor sampling that identified a third groundwater plume. It's the comprehensive soil vapor monitoring network that contributed to the robust and complete conceptual site model for the project. And these soil vapor plumes, they extend through 8 residential communities and 3 commercial properties. And there are 447 soil vapor probe locations to monitor the extent of the plume and its stability. And for select communities, those soil vapor locations are utilized to evaluate indoor air results with. And then at each location, there is typically probes at 5 and 15 feet below ground surface. Next slide, please. So for the indoor air investigation, there are 622 homes that have been offered indoor air sampling. Of these homes, 415 have been sampled at least once, and these homes are located within those 8 residential communities. One thing I'd like to note is regarding the indoor air investigation, with so many residential homes being evaluated, homeowner privacy was a big concern and of great importance to everyone involved in the investigation, but especially the homeowner and tenants. But it was also important that the reports provided the indoor air results. Therefore, non-descriptive property IDs were assigned for each home, and only the project team has the key. This was the best approach for this project to be transparent about the results while maintaining homeowner and tenant privacy. All right, and then I'll add for communicating the indoor air results, those are sent separate to the homeowner and or tenants. And the indoor air results as a whole are included in a tabulated table in the routine monitoring reports. All right, next slide, please. So public outreach has been a large component of the vapor intrusion investigation. So I do want to touch on it briefly because community engagement is incredibly important to us. It's written in the regulations, and it is included in step 3A of the supplemental guidance. Public outreach, community engagement is incredibly important. So I want to emphasize that. We've been conducting public outreach for this site since 2018, and there are 11 communities that have been impacted as part of the investigation. There are we've had over 30 public meetings. 14 of them were community-wide meetings that provided regular project updates. and over 20 that were community specific, which occur as needed to discuss things like risk assessment results or proposed remedial actions. We've issued 15 fact sheets that have been distributed, or 15 different distributions of community fact sheets, and each distribution goes to over 1,900 addresses. Work notices are distributed via US mail about a week prior to work. There's community email updates when necessary. The responsible party created a project website and toll-free hotline, in addition to the State Water Board's database GeoTracker, where all of the analytical results, reports, public meetings have information uploaded there. We hold one-on-one briefings with residents to discuss their indoor air results as needed. And the primary concerns from the residents really have included real estate values, inconvenience, need to do the work, and potential health impacts. And then lastly, plain language summaries have been added to select reports because these community members are reviewing the reports, and this has helped with their understanding of the content of the report. Next slide, please. All right, so now we're going to start talking about 4 vapor intrusion scenarios that's been encountered during this project. Now, this is not a complete list, but 4 that I would like to highlight. The first 2 are straightforward scenarios. It's the last 2 scenarios when there are indoor air detections, but additional supporting lines of evidence are needed to support the conclusions. A significant contributor, I will add, to being able to confidently reach the conclusions is attributed to the robust conceptual site model and sufficient lines of evidence to support the conclusions. Next slide, please. All right, so now let's talk about those lines of evidence. I want to highlight that the supplemental vapor intrusion guidance, attachment 1, goes into depth on lines of evidence. So I'm not going to do that, but I want to highlight how they have been used on this case. Since each building is unique when it comes to preferential pathways and heating, ventilation, and air conditioning operations, it is necessary to evaluate each building. And the supplemental guidance also supports this approach. Now, for the project as a whole, we have a number of lines of evidence due to the robust conceptual site model that support the conclusions we make when reviewing the indoor air results. But sometimes we need some additional lines of evidence not included on this list, and I'm going to point those out in the next few slides. But I also want to point out that, modeling, while it's a line of evidence, it is supplemental. It's a supplemental line of evidence. It's still necessary to collect those indoor air samples and to screen and evaluate each building first. Also, here, the crossed out lines of evidence were just simply not applicable for this site evaluation. Next slide, please. Okay, so the first scenario I want to go over is when we have subsurface concentrations that exceed screening levels, so indoor air sampling occurs. The indoor air results are below the laboratory reporting limits during both seasonal sampling events, so we were able to conclude no vapor intrusion is occurring and current risk is below the point of departure. Now, the future risk, that's where we're looking at the existing soil gas concentrations, and those are modeled to evaluate the risk, and then risk management decisions are made based on those results. And this has been the approach for all buildings within the indoor air investigation area. And I know there was a question off of the last presentation, and when is that temporal sampling enough? And it really does have to do with the subsurface results, the future risk. Was the indoor air concentrations, was it below reporting limits? Was there some detections, but below the risk thresholds? So these are the questions we're asking and looking into and utilizing the multiple lines of evidence. Next slide, please. The next scenario includes when you have subsurface concentrations that exceed screening levels. And for this home, indoor air results identified TCE in indoor air at concentrations up to 16 micrograms per cubic meter, which exceed the TCE action levels. Now, for this home, cracks were observed in the room with the highest detections, and I'm going to show those on the next slide. Therefore, for this scenario, we went ahead and did immediate mitigation measures were deployed when the confirmation samples were picked up, air purifiers were dropped off. And then later, sealing of the identified cracks was coordinated with the homeowner. So next slide, please. All right, so for this home, let's first talk about these short-term mitigation, short-term solutions, next steps. With the room with the highest detections was in the garage, but it had been converted to a playroom. So it was actively used by the family. And it's where the building survey is so crucial, that you understand how each home is and room is being utilized. The top picture points out cracks that were observed during the building survey. So this potential preferential pathway was targeted when placing the indoor air sampling location canisters. They placed it near, still at breathing height, but near those cracks. The bottom right photo shows the floor as it was being prepped and those cracks sealed. And that bottom left photo shows the completion after sealing the entire floor in this room. Now, subsequent indoor air sampling did confirm that sealing the floors addressed the pathway in this room, but it didn't address vapor intrusion for the rest of the home because removing the existing flooring was just not an option. The air purifiers were able to reduce the indoor air TCE concentrations to below the action levels, but there were still some exceedances of the long-term screening levels. Next slide, please. So long-term solutions for this home needed to be considered and addressed, and this included subslab depressurization system. Now, the photo on the top right is of the SSD system. It's located on the outside of the home, and because of the size and community feedback, enclosing the system was done, which is shown on the photo on the bottom right. A soil vapor extraction system has also been installed in this community to address the soil vapor plume, which is shown on the photos on the left. And there is ongoing indoor air sampling to confirm the effectiveness of the long-term solutions, and continued soil vapor sampling has been conducted to evaluate plume stability and the remediation effectiveness. All right, next slide, please. The third scenario covers a situation where additional lines of evidence were needed to support the conclusion. We had subsurface concentrations exceed screening levels. In this case, it was for PCE, and indoor air results exceeded the screening levels also for PCE. Now, the building-specific attenuation factor was consistent with the site-specific attenuation factor and data collected using traditional sampling methods of canisters for those indoor air samples and grab samples for soil gas. So we concluded that vapor intrusion was occurring because the building survey had not identified an indoor air source. Therefore, we did request that the RP move forward with long-term mitigation measures while longer-term remediation plans were being evaluated. But the, prior to moving forward with implementing a long-term solution, the responsible party requested collecting additional lines of evidence to confirm vapor intrusion, which we approved, and they therefore conducted some continuous indoor air monitoring. Next slide, please. So before we talk about the continuous indoor air monitoring, I just wanted to show the site and building specific attenuation factors and why we had originally concluded that vapor intrusion was occurring. Since there's such a large data set for this project, the site specific attenuation factor is the 95th percentile value. And these results are also why we continue screening each individual building. The building-specific attenuation factor, in this scenario, we just calculated the average for this particular home where this scenario had occurred. For this community, The foundations are post-tension support, so there's no subslab pins, which is why we don't have a building-specific attenuation factor for subslab to indoor air. Now, for other communities, we do, and that's how that was developed for the site as a whole. I do want to point out that I have heard post-tension support foundations tend to have more intact foundations, but on this project, the communities with the post-tension support foundations are where we have seen the most vapor intrusion. Now, I'm going to say, I am not saying that is what's contributed to it, but what I am saying is this is why it's important and necessary to screen each building and not solely rely on assumptions, but instead make those data-driven decisions supported by multiple lines of evidence. All right, next slide. So this image on the slide are the results from the continuous indoor air monitoring. The black line represents the indoor air concentrations in the laundry room, and the other lines below it represent indoor air concentrations at other areas of the home. And what this was able to identify was the laundry room had an indoor air source that had not been previously identified during the building survey. Following removal of that indoor air source, the home was resampled and concentrations were below screening levels. So based on this, it was concluded that PCE identified in indoor air was attributed to the indoor air source, and subsequent indoor air sampling has confirmed this. All right, next slide, please. Okay, so the final scenario I want to go over is scenario 4, which covers a situation of when is coincidence more than coincidence? Here we have 14 homes that are sampled on one street. Again, we have a really large vapor intrusion indoor air investigation area. And here we have a single street, 14 homes that have been sampled over the course of several years. Detections in these 4 highlighted homes occurred over a span of several years because they participated in the vapor intrusion investigation at different times. Now, at first glance, with the first home that had an exceedance of TCE in indoor air, the conclusion was not that it was vapor intrusion, but an indoor air source based on lines of evidence. We even drew the same conclusion with the next home. But when 2 more homes had exceedances on the same street for the same COC, it was important to lean into the additional lines of evidence a little more. Next slide. And we did this because for this location, this is within the former facility, near areas of historical known subsurface impacts that were historically remediated. Now, the soil-only closure allowed the site to be rezoned from industrial use to residential use. So single-family homes reside over these areas. Knowing this and identifying this cluster of homes with TCE exceedances, we had to look at multiple lines of evidence to support our conclusion. Now, as regulators, it's our responsibility to ensure the protection of human health and the environment. And for scenarios like this, it's important to evaluate the uncertainties. Next slide, please. So here's just a list of some of the multiple lines of evidence that were evaluated during this scenario. And I'm not going to go over this list on this slide because we're going to talk about it on all of the subsequent slides. So next slide, please. All right, so the first line of evidence was the building survey. Now, some of these homes had identified potential indoor air sources, including a house cleaner and recent remodeling and painting, but not all of the homes had identified potential indoor air sources. Next slide, please. Another line of evidence that we were looking at was the fact that the detections were sporadic. When considering all of the homes with exceedances, it was identified that the detections were sporadic and often the confirmation sample results were below the reporting limit. So that again led us to believe it wasn't vapor intrusion, but there was still that uncertainty. So we were looking at the other lines of evidence. Next slide, please. So we were also evaluating the indoor air results to the subslab soil vapor concentrations. Here, I'll point out that because of access limitations, we could get one sub-slab pin installed and it was located in the garage. So it's not a solid line of evidence, but it is useful. So we evaluated those sub-slab concentrations to what was identified in indoor air. And if both COCs were identified in the subsurface, but not in indoor air, it was just another line of evidence support an indoor air source. Next slide, please. Now, since the sub-slab results were limited, we did need to rely on nearby soil gas probes as well. And we evaluated plume stability and concentration trends for results collected from both 5 and 15 feet below ground surface near these homes. And these results indicated decreasing concentrations for both PCE and TCE, and both 5 and 15 feet below ground surface. So that top concentration trend graph is for TCE. The triangles are the 15-foot probes. The circles below it are the 5-foot probe depth concentrations. And then the concentration figure below that is for PCE. Again, triangles is for the 15-foot depth. And the circles are for the 5-foot depths. Next slide, please. All right, so the last line of evidence that we looked at was actually evaluated earlier in the indoor air investigation process and was tied in with the first home on the street that had the TCE exceedance. Again, since this location is the former facility and remediated in the 90s, and for the first home, the TCE exceedance was in the bathroom, there were some uncertainties. So we looked at the sewer pathway. Air samples were collected from the manhole nearest the home and from the upflow and downflow directions of the sewer. And these samples all came back as non-detect for TCE. Now, I mentioned at the beginning of this scenario that it's important to evaluate uncertainties. So we are evaluating potential vapor intrusion for the protection of human health. So we didn't want to make conclusions based on assumptions when uncertainties are identified, which is why those multiple lines of evidence were evaluated. Well, these lines of evidence concluded vapor intrusion was not occurring, so we could move on, which is what we did. All right, next slide, please. And so I just want to highlight some of the best practices that were used for this case that resulted in a successful vapor intrusion evaluation. There are some key components that I want you to remember. First, collaborative communication is key, especially between regulatory agency, responsible party, and consultant. Second is taking an adaptive approach. We've kind of referred to it interchangeably, either adaptive or a holistic approach. It's important to accept and incorporate project feedback from changing industry standards to new data collected at the site. And third, transparency, being upfront and honest, especially when dealing with the public. Next, when there's a robust understanding of the contaminants in the subsurface, an indoor air analyte list is supported. And this helps to eliminate the potential noise of indoor air sources, and it simplifies risk communication with building occupants. Finally, it's utilizing steps from the supplemental vapor intrusion guidance to protect people faster, which includes step 1, prioritizing buildings and select the appropriate sampling approach for your site based on historical site use, previous analytical results from groundwater, soil, and soil gas. Step 2 is evaluate potential vapor intrusion risk with soil gas results. Step 3 is to confirm if vapor intrusion is occurring or not with actual indoor air samples collected in multiple seasons. And finally, step 4, evaluate risk, both current and future, and use the risk evaluation to make risk management decisions. Next slide, please. So I just want to close by highlighting how we utilize the key principles of the supplemental vapor intrusion guidance and other relevant vapor intrusion guidance documents to conduct the vapor intrusion investigation, which ensured quality data was collected and used in those human health risk assessments that were later generated. Now, I do want to point out that if vapor intrusion was identified, we went straight to step 4 of the supplemental vapor intrusion guidance and made risk management decisions to implement short-term mitigation measures as necessary. Now, the results from the human health risk assessments, which included current and future risk, are what were used to develop and support the cleanup strategies and path forward for the site. Now, for the shameless plug. For those interested in the risk management decisions, including that future risk management and path to closure for vapor intrusion, I'm going to be talking about that during the next workshop in May. Next slide, please.
All right. Thank you so much, Jessica. That was an awesome presentation. I know it's already been dropped in the chat. We are running overtime. We thank you guys so much for joining us today. We are going to go ahead and continue with our Q&A session. We're going to go ahead and skip this break. We understand that if people need to, go ahead, do whatever you need to do. Come on back. The Q&A is being recorded today, and it will also be posted online. So you will be able to hear responses to questions. All right. So with that, just another reminder here. I did just, or actually before that, I wanted to just say a quick thank you to all of our presenters today, Andrew, Jay, Saru, Jessica, for the great presentations. And we'll go ahead and move into the Q&A. Next slide, please. Thank you very much. So just going to run through the logistics real quick again for the Q&A sessions. As you were doing before, please go ahead and keep putting questions into the Q&A feature. Our team is busy answering those. Also, go ahead and do the raise hand feature if you would like to ask your question verbally. Everybody is muted until given permission to speak. And when we do call on you, we ask that you state your first and last name and your affiliation. For our phone users today, again, just a reminder, please press *9 to raise your hand and *6 to unmute yourself when prompted. Let's see, anything else here? Not too much. All right, let's go ahead and get started. So we do have a quick couple follow-ups, Jessica, for you right off the bat. So first is for the garage converted to a playroom. You mentioned the indoor air samples were collected from the breathing zone. Was the sample height adjusted as children are usually shorter than adults?
Yes, they were. And again, this is why it's important to have those conversations, know the building occupants, who's using the rooms, who's living in these homes. So yes, they were adjusted.
Great, thank you. And then also, still for Jessica, based on the second case study or scenario 2 of the project, were the homes not installed with vapor barriers?
They were not. These homes actually were, this community in particular was developed before the facility was even closed. So before any investigation or remediation had actually occurred on the project.
There we go. Sorry, I missed my mute button there for a second. Thanks, Jessica. I'm going to go ahead and jump over to the hands real quick, and then we'll come back to the Q&A. So first up, I see Javier Hinojosa, and I'll go ahead and allow you to unmute. When you are able, go ahead and unmute, share your name and affiliation, please.
Good afternoon or good morning to all, and congratulations on a fabulous presentation. I had a question about setting cleanup goals for soil that's contaminated with VOCs if you don't have any buildings and you've already have sufficiently characterized laterally and vertically and collected sufficient temporal and spatial analysis. How do you set up a cleanup goal with what, and maybe even you have J&E model results as well?
Yeah, great question. Thank you, Javier. I'll go ahead and look to the CalEPA work group, see who would like to come on and assist with answering Javier's question.
Julie, I can take the first shot.
Thanks, CY.
Since Javier put my name in one of his questions, and thanks for the comments, Javier. First, I think this is really the goal that agencies is aiming by conducting this series of workshop to use the holistic approach. including a robust CSM, take advantage of site-specific lines of evidence, which modeling is one of them, and also use of the risk-based tool to support site-specific AF, and in the case where there's no building. And I think previously you posed the question, if there are pale indoor air or subset data for existing building, those will be a very useful line of evidence. But regardless, I think the AF itself is just like other lines of evidence. It's just one of the consideration we take into account. And previously, I think several CalEPA member mentioned about looking at the strength and of the residual and the building condition. Those also need to be taken into consideration. But certainly, when there's no building, we probably will start with some quantitative evidence, whether it's use of the model or use of some kind of default attenuation factor, if supported by the CSM, we may be able to adjust the default based on site-specific condition. But ultimately, you probably heard the answer. All right, it's all site-specific, but at the same time, I think we're doing this workshop, and then later this year, we're going to conduct the training to our regulator. Hopefully, we can promote more transparency and consistency. But again, appreciate your question and comments.
Thanks very much, CY. And thank you, Javier. All right, I see one other hand up so far. I will go ahead and allow. I will go ahead and allow to unmute. So LaDonna Williams, if you're able, go ahead and unmute. Please share your name and affiliation.
Yes. Good morning, LaDonna Williams. I am with a small community-based group, All Positives Possible, in the San Francisco Greater Bay Area. So I want to ask, and it's unfortunate that I have to keep saying this after 30 years, but it has been 30 years experience with DTSC, Water Board, these responsible agencies. And well, first and foremost, I wanted to say thank you for the presentation. It was very informative, but I would also like to see in the future case studies that actually fit our lived experiences. And when I say ours, that's living in a low-income, disadvantaged complex or property that was a former junkyard or a garbage dump, and they allow housing to be built on these sites. And unfortunately, we're currently involved with a site with a similar name, which they tend to label our sites urban ghetto sites with the name village on the end. There's a practice, though, that they've now begun to rename these sites. So when you go looking for information, those sites' names have been changed. So it's difficult to find the locations to get, or not the locations, but the information, so that you get historical information on what has happened and what has been built. And it's a lot. You guys gave us a whole lot to put together. So I apologize in advance if I'm all over the place. Well, no, I'm not going to apologize. I just say, please bear with me. My question is, what PID, what handheld PID could residents who have finally discovered that they've been living on a toxic site after years of illnesses and trying to figure out what's going on, and that it's more than just getting old and your body breaking down, that you've been exposed to various vapor intrusion sources. What handheld device would be recommended for indoor exposure levels for residentials, whether it be a home or whether it be in our case, low-income housing being built on these sites, which means they haven't discovered, like was in the presentation, a new exposure source. They've had historical facts and information of what is in those areas that's causing these various illnesses that, in our opinion, in our experience, neither agency will acknowledge. They point the finger at each other as far as who is the responsible parties that should be taking lead over the project. Is sort of throw it up in the air or throw a dart at the wall to determine, will it be water boards? Will it be DTSC? Like, our lives have literally depended on it, those of us that have survived it, to even be here and ask this question. I'm just wondering what is actually being done other than studying us to death like lab rats, or what we call the rabbit has died test cases.
Yeah, thank you so much, LaDonna, for your question and sharing your experience. We really appreciate you doing that. And I will go ahead and look to our CalEPA work group to see who would like to come on and begin a response.
Hi, Donna, and LaDonna, right? That's great.
Yes, LaDonna.
LaDonna, and thank you for the conversation on this. I think our underlying goals with our agencies is to help these communities. And I'm not familiar with what area of the state you're talking about. I do know, and I don't know if you attended our last vapor intrusion and community workshop. We do understand that there's quite a big impact and historical imbalance with some of the contaminated sites and industrial uses in some of these areas of the state. So for me, that's very important. And working with our regional boards and our sister agencies on helping us understand the impacts to these communities better. I do recommend that maybe we can have an off call to talk more site specific with you.
Okay.
There are concerns you have for a certain area, maybe we can get together to talk. And if somebody wants to put, or I can put it in the chat, I'll put my email address if you want to reach out to me, and we can discuss further on this topic. And,
okay, we can definitely do that. And just for to follow up, the site is located, you mentioned you weren't familiar with the possible area. One of the sites is located not too far from the San Francisco airport, the historic Cow Palace building. Depending on what side you look at, it may say San Francisco or it may say Daly City, but that was a former Midway Village site in Daly City. And then the current site is located in Vallejo, California.
Great. And would you object to if we brought in our San Francisco Bay Regional Board as part of the conversation?
Oh, absolutely. We invite any and everyone that is willing to listen.
Okay. All right. Well, let me throw my email in the chat if you want to get hold of me. That'd be great.
Okay, thank you.
Wants to chime in too, please do so.
And LaDonna, I'm sorry if I missed it, but do you know if these are waterboard or DTSC sites, the two that you're referring to?
Well, that is the problem. Both of them are listed, and that is kind of what I was bringing up. And it's been the standard practice that we found that they sort of point the finger at each other as to who should be the responsible party. And then as time goes on, I guess they've determined it's the water board. And we've asked, what procedures or what boxes do you check off that determines who has the, oversight or responsibility? So in the case of the one located in Vallejo that we're currently working on, it looks like, according to GeoTracker, it's the water board, and the previous site was DTSC.
Thank you. I'll put my contact information as well. If you have any follow-ups with DTSC, you can contact me directly.
Okay, so wait, Steve? No, you're. It flashed off. I was trying to see who's the names that we're talking.
So Steve's with the water board. I'm Craig, and I'm with DTSC.
Oh, okay.
Yeah, thank you. Nice to meet you. Thank you for your question.
Thank you.
Yeah.
Thank you so much, LaDonna. We really appreciate it and look forward to future conversations with you.
Thank you, guys.
Thank you. All right, I'm going to go ahead and look back at our Q&A. I don't see any hands up at this moment. So I'll go ahead to the question here. There's a couple more specific for Jessica. Jessica, if you're still online. Let's see. For the air purifier, how many pounds of carbon did the purifier have? They're just wondering if some of the smaller air purifiers would only like 5 pounds of carbon would work.
You know, I don't recall off the top of my head how much carbon the air purifiers have, but I will say that is why there's the longer term monitoring that is going on for these homes with vapor intrusion, or where we've seen the complete pathway, and then looking at future risk as well. So we have ongoing indoor air monitoring to evaluate the effectiveness, to make sure it is working, and to help with some of these subsequent decisions that we've made, risk management decisions that we have made on this project.
Great, thanks, Jessica. And then also another great presentation, Jessica. They have to attend another meeting, but how would you feel if we distinguish between a line of evidence that is inferential versus a definitive line of evidence? So looking specifically, I specifically identified indoor sources. It's kind of an interesting question.
It is an interesting question.
Yes.
You know, that's why from a regulatory perspective, when we have those kind of, like I refer to them as that solid line of evidence, that empirical data, this is where, you know, in that scenario 3, we had the continuous indoor air monitoring that kind of finally pointed to this laundry detergent that hadn't been identified during the building surveys, even though we were seeing higher concentrations or these elevated PCE concentrations throughout the home. It didn't have that. The laundry room is the source room for this. It wasn't identified until that continuous monitoring. And then those inferential kind of lines of evidence helped to be that follow-up in the decision making. So identifying that source ended up saving time, community impact, because there was no longer the need to put an SSD system on the home, which is intrusive. It's a lot of community impact, and if it's an indoor air source, it's not going to have any lasting effect, which is a waste of time resources. So there you go. I hope that answers the question, Mark.
I hope so. Thank you so much, Jessica. Appreciate it. And we did see this answer many times in the Q&A, so I just figured that, Jessica, I know you just took yourself off camera, but if you would please come back, I'll ask out loud for you to talk about just a little bit. What was the indoor source, the indoor air source in the laundry room?
It was a laundry detergent. I don't remember the brand name, but when they finally identified it during the continuous indoor air monitoring, and they looked at the ingredient list, it had tetrachloroethene on the list of ingredients. And so it ended up being the source. And truly, as they removed that product and communicated that with the homeowner, the subsequent sampling events, we have not seen it. And again, this was unique in that there was a kind of nugget of PCE soil vapor impacts right at the location of that particular home. And so the lines of evidence, those initial ones, really lined up to be it was vapor intrusion, which is why it's really good to look outside of what we know and get a comprehensive look.
Excellent. Thank you. Yeah, I think we had about 4 or 5 questions in the Q&A about that. So thanks, Jessica, for talking about that a little bit more. Let's see. Looking to our Q&A and to our hands, I don't see any hands up right now. I do see another question in the chat right now, and it says, was PCE actually listed on the laundry detergent ingredients on the bottle, or did you need the SSD?
So my understanding from the consultant is that it was listed on the bottle. But I'll have to confirm, but from what I recall from those conversations was they saw it as an actual ingredient on the bottle.
Got it. Thanks, Jessica. Yeah, lots of great questions. Thank you all. So there is a follow-up here, and I do see that Steve is typing a response, but I'll go ahead and ask this question, Steve. So it's how is it determined if a site with vapor intrusion concern from solvents falls under DTSC or water board's oversight?
And I see my typing wasn't fast enough, so I'll just answer this.
Thank you, Steve.
Our agencies tend to follow, we have a memorandum of agreement between our agencies that we typically follow. If the site is typically just a human health threat, soil impacts like lead, that's going to be a DTSC lead site typically. We do have exceptions here and there. If there's a water quality concern, then the water boards will likely be the lead oversight agency. We also have a number of our local agencies out there implementing the AB 304 voluntary cleanup program that they can provide oversight as well. And for LaDonna's facility, it does sound like the water boards have been heavily involved, so we would probably stay involved in those projects that was discussed. We're having a little side conversation about this with the team here. So hopefully that answers your question. I do believe that MOA is online, so you can look it up if you want to see how we make that determination.
And I just dropped the link to that MOA into the chat. And I think we'll find the website for DTSC that also talks about that, and we can provide that link as well. Thanks, Steve. And with that, I'm looking at the hands and the Q&A, and it looks like there are no other questions and no other hands. So okay, I'll give it a count to about 1, 2, 3, 4, 5. Still seeing none. And with that, we'll go ahead and start wrapping up the workshop. I do see a question real quick, requesting copy of slides. I will get right to that. Next slide, please. Thank you very much. So just as a reminder, today's workshop was the third in the CalEPA VI Workgroup's 2026 workshop series. Next up is the Holistic Approach Part 2, Path to Closure and Collective Decision Making, which will be taking place in May, that Jessica did a shameless plug for, so we really hope you join us for that one. The final workshop in the series will be Vapor Intrusion Data, and that'll be held in June. So notification emails, again, will be sent out on our listservs, and registration links will be posted on the State Water Board's and DTSC's websites when they are available. Next slide, please. So again, if you'd like to request a copy of the materials today, or if you think of additional questions, please reach out to us at dwq-vaporintrusion@waterboards.ca.gov. The presentation slides will be posted on the State Water Board's FTP site. So if you requested the slides previously, you already have the login information. Just give us about a week and a half to get those materials online. All of the workshops are recorded, and links to the recordings are being posted on the State Water Board's and DTSC's vapor intrusion websites. We really appreciate your patience as we work to get the materials online and available for you. So I'd also like to just give a quick reminder about the Zoom survey that will be sent to attendees after the workshop. If you have time, we would greatly appreciate your feedback. And with that, I'd like to thank you again so much for your time and questions and comments today. Have a great rest of your day, and we look forward to seeing you in May for the Holistic Approach Part 2, Path to Closure and Collective Decision Making. Thank you.